Hello there, and welcome back to the Sleep Science, where the universe hums just a little quieter once the lights dim and everyone else has gone to sleep. Tonight, the feed from NASA's main servers is dark, and you can almost hear the silence between the stars. On every glowing monitor, error messages bloom like tiny eclipses. Site temporarily unavailable due to government lapse in funding. You probably won't survive this, at least not without a cup of tea and the comforting illusion that someone somewhere is still watching the sky for you. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Tell me in the comments where you're tuning in from and what time it is where you are. I love knowing the world still spins while we drift through space together. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You sit back and picture the red planet hanging low in the darkness, a quiet sentinel orbiting beneath the dusty breath of the sun. The United States government shutdown has wrapped NASA in an uneasy pause, like someone pressed the cosmic mute button. Twitter feeds, livestream dashboards, and mission blogs, each one has gone still, their last updates frozen like photographs of a vanished moment. Mars, however, keeps spinning, completely indifferent to bureaucracy. Its thin atmosphere sighs across ancient dunes, and far below that salmon-coloured sky, the Perseverance rover is still alive, still listening, still turning its little camera eyes upward when commanded by lines of code sent long before the budget arguments began. You picture the rover's metal hull glinting faintly under the dusty afternoon. The sun is a bit smaller from there, a harder coin of light. Somewhere above that horizon, just out of sight from Earth, the object called 3I/Atlas is slipping into view, if of course it's really there. The headlines call it Interstellar, the catalogue calls it a comet, the observers call it a mystery. It's moving so fast, 60 kilometers per second, a streak across the solar system's neat circular lanes, and it has chosen this precise week, of all possible weeks, to swing by Mars while humanity's biggest space agency is offline. The timing feels like a cosmic prank. You lean closer to your imaginary monitor, the one in your mind that's still glowing even though NASA's real ones have gone dark. In your mind's eye, you bring up a chart, a thin arc representing Mars' orbit, a dashed line showing Atlas's path. The two almost kiss at a point just 30 million kilometers apart. Close enough for whispers, not collisions. And in that closeness, the possibility of seeing something new flickers like static. For decades, astronomers have dreamed of catching an interstellar object in real time. They did it first with Oumuamua in 2017, a cigar-shaped mystery that accelerated oddly as it left the inner system. Then came 2I/Borisov in 2019, a more traditional comet, though its chemistry defied expectations. Historians still argue whether Oumuamua's motion was natural or powered, dust-driven or alien-made. The debates never really ended, they just became memes. And now, in the hush of a government shutdown, the cosmos may have delivered the sequel no one was ready to record. The silence of NASA's servers makes every rumour louder. Amateur astronomers whisper through forums, a green glow spotted from Namibia, a faint anti-tail pointing sunward, a shape that refuses to sprout a comet's proper plume. Somewhere, someone claims the Perseverance rover captured a strange streak across the Martian sky, a line not aligned with the planet's rotation. You imagine scrolling through raw images, little rectangles of grey dust and static, the horizon tilted, the stars forming faint vertical smears. Then, there it is, a diagonal thread slicing the frame, brighter than it should be. Is it a cosmic ray, a trick of the exposure, or the flash of Atlas itself crossing the field? You lean back again, hearing only the fan and your own breathing. The human brain is allergic to uncertainty. It would rather invent stories than sit quietly and not knowing. So naturally theories bloom. Some say Atlas is a fragment of a shattered exoplanet. Others, half seriously, call it a reconnaissance probe, an alien survey ship disguised as a comet. You smile at the absurdity, and at the faint tremor of excitement that it might not be absurd at all. The great cosmic joke is that the universe doesn't clarify, it just sends another riddle wrapped in plasma and dust. Down in Mission Control's empty rooms, the lights of the Mars tracking board are still blinking. Essential systems never sleep, shut down or not. Deep space network antennas keep murmuring to the void, capturing telemetry packets like snowflakes. Somewhere in California, one overworked engineer, technically furloughed but unable to resist, probably has a personal laptop tuned to the raw feed anyway, watching for a spike, a flicker, a blip that could mean interstellar news. You can almost hear the keyboard clicks echoing through the silence of policy gridlock. Outside your window, the real night presses close. You trace Mars's location in your head, a reddish spark currently near the sun's glare, impossible to see with the naked eye. The irony bites. A once-in-a-lifetime visitor is approaching the red planet, but Earth's own brightness blinds us to it. You imagine the spacecraft scattered around Mars, ESA's Mars Express, the Trace Gas Orbiter, the Chinese Tianwen 1, the Emirati Hope Probe, all quietly continuing their routines. The Europeans, at least, have already confirmed they'll swing their instruments toward the interloper. Science, it seems, still finds a way, even when politics pulls the plug. You breathe out slowly. There's comfort in knowing that the universe doesn't notice our deadlines. A solar wind gusts, a cosmic dust grain melts, an interstellar rock passes by, and none of it cares whether Congress funds next week's operations. Historians of spaceflight often remind us of 1973, when a previous funding crisis almost shut down the Skylab missions. Historians still argue whether that near pause cost us critical data about solar flares. You think about that as another potential chapter unfolds. Will they someday debate whether the 2025 shutdown cost us the clearest images of an interstellar visitor? Probably. And somewhere, a graduate student in 2080 will still be quoting a missing file from this week, cursing at a corrupted data log that should have been uploaded but wasn't. Your thoughts drift to the red planet again. You picture its atmosphere glowing faintly with auroras from the same solar storm that hit Atlas a week ago. If Mars had eyes, what would it see? Maybe a green-tinged visitor shimmering against the sun's light, its coma expanding, its core shadowed and complex. Maybe nothing at all. The Perseverance rover's cameras might record a streak too faint for our eyes, yet still bright enough for algorithms to flag later, long after the shutdown lifts. You reach for your tea, cold now, and think about the way human attention works. We're brilliant at building telescopes, terrible at keeping them funded. We can detect a hydrogen molecule 400 trillion kilometers away, but we can't agree on next month's budget. There's something oddly poetic about that, as if the universe enjoys testing our priorities. Maybe Atlas came now just to remind us how small our squabbles look from interstellar space. The fan hums, your eyelids grow heavy, you start to imagine that you're standing on Mars yourself, the horizon stretching flat and endless. The wind brushes dust across your suit. Above, the sun is a smaller, whiter disk, and beside it a pinprick of green moves fast. Too fast for a star, too steady for a meteor. You raise your gloved hand to shade your eyes. For a second, you almost believe you can hear it, a faint electric whisper carried on the thin air like the static between radio stations. Maybe it's nothing. Maybe it's everything. Then the moment passes. The sky darkens again, Mars spins on, and back on Earth the shutdown clock ticks toward resolution. Somewhere a server hums back to life. Somewhere else, a new image upload begins, timestamped 2025-10-040000 UTC. You imagine the first pixel appearing on screen, a fuzzy dot, elongated, slightly off colour. Engineers will argue for weeks whether it's artifact or evidence. Historians will argue for decades whether the timing was coincidence or cosmic irony. And you just sit there, half smiling, letting the soft hum of the fan blend with the imagined hum of space itself. The next morning begins without a sunrise, at least not one you can see. The news feeds are still dimmed, social media still half asleep under the grey blanket of the shutdown. You rub your eyes, glance at the empty dashboards, and feel that familiar itch of curiosity tugging at your mind. Somewhere out there, above the Martian horizon, that streak of light from Perseverance's cameras is still haunting the data logs. You picture the rover as an insomniac photographer, sitting in the sand dunes with its lens pointed toward an indifferent sky. The faint streak slices across its frame again and again, steady as heartbeat, defying all the slow drifts of the stars. If you could step into that frame, you think, you'd hear nothing at all, just the whisper of dust hitting metal, the steady ping of cosmic radiation on circuitry, and then that soft shiver of something moving far too fast. 9 minutes of exposure data, 9 minutes where the Martian night turned into evidence. You imagine the engineers back on Earth, well, at home, technically, staring at those images from their personal laptops, comparing each faint speck, trying to decide what's real. The elongated stars mark Mars's rotation. The strange diagonal thread runs counter to them. It's not an artifact, not a lens flare. Even the cynics admit it's something solid, moving across the sky in a way that makes math tingle with possibility. Historians still argue whether the first long exposure streaks of satellites from the 1950s were blessings or curses for astronomy. Tonight, that same argument flickers back to life on encrypted Slack channels and unmoderated forums. You scroll through your own imaginary dataset, eyes adjusting to the soft grayscale. The streak almost glows when you look directly at it. Could it really be 3i/Atlas? The numbers fit. The timing, the apparent speed, the direction of travel relative to the ecliptic. If so, it means that for the first time, a machine on another planet just recorded an interstellar visitor. The thought makes your skin prickle. It's the kind of event that should have triggered emergency press releases, coordinated statements, celebratory chaos. Instead, you have nothing but quiet and a single fan humming beside you. There's something poetic in the idea of Perseverance watching the stars for us while we bicker about budgets. The rover wasn't built for this kind of work. Its cameras are designed for rocks, not comets. Yet even limited optics can catch wonders when the universe insists. You remember how the Viking landers once captured the first Martian sunsets? Tiny, blue-rimmed discs that made scientists cry in dark rooms. This feels like that again. Only stranger, faster, more impossible. The rover doesn't know that Earth's news outlets are silent. It just keeps taking pictures because that's what it was born to do. You think about how exposure works. The slow gathering of photons, the patient waiting while the planet turns. On Earth, you'd call it long-form photography. On Mars, it's survival. A single frame can take minutes to process, and in that time the world keeps moving. Every pixel becomes a tiny act of faith that the sky won't change too much while you wait. But tonight, something did change. Something burned its signature across the sensors, a moving line, alive and definite. If Perseverance could talk, it might ask, "Did you see that?" And you'd whisper back, "Yes, we did, or at least we think we did." You stretch, glance at your reflection in the dark monitor and chuckle softly. It feels absurd to treat a rover like a friend, yet here you are, cheering for a six-wheeled camera trapped 40 million miles away. Maybe that's what astronomy really is, the art of feeling companionship with machines that outlive our politics. Historians of technology often debate whether our probes are extensions of ourselves or entirely new beings. They still argue whether the Voyager Golden Record was meant for aliens or for us, a self-portrait cast into space. If that's true, then every new image from Perseverance is another self-portrait, this one showing a human species peering through bureaucracy at the infinite. You decide to imagine the night as Perseverance might see it. The temperature drops below -70 degrees Celsius. Frost clings to its robotic arm. The camera turns slightly upward, the stars shimmering faintly through thin dust. Then, across the frame, a streak appears, white-green, almost playful. It moves faster than any satellite, straighter than a meteor, and it lasts just long enough for the rover to notice. In that moment, the universe becomes a little less predictable. You can almost hear the hum of its motor pause, as though it's holding its breath. Back on Earth, the amateur community does what it always does when officials go silent. It collaborates. Images appear on hidden Discord servers, stacked and cleaned by people who should probably be sleeping. Someone compares the coordinates, another calculates angular velocity, a third overlays a map of known debris orbits. The conclusion feels unanimous but unspoken. This is no local object. It's moving at 60 kilometers per second relative to the Sun, and its trajectory runs nearly parallel to the ecliptic. The probability of a misidentification? Less than 1%. You exhale slowly, realizing that you might be among the first 1,000 people on Earth to understand what that means. Yet even understanding feels incomplete. There's no way to confirm without NASA's deep data channels, and those are locked behind out-of-service banners. The irony could fuel 1,000 late-night jokes. Humanity discovers an interstellar object and then collectively forgets to pay the cosmic Wi-Fi bill. Somewhere, you're sure, a future textbook will include a footnote about this week. How the Perseverance anomaly coincided with a national shutdown, how the delay in official confirmation made half the world believe and the other half doubt. The pattern isn't new. Historians still argue whether Galileo truly saw Saturn's rings, or just misinterpreted his telescope's blur. We never seem to change, we just argue faster now. You close your eyes and imagine the streak one last time, the way it must have burned across those digital sensors. Maybe it wasn't 3I/Atlas at all. Maybe it was debris from an old probe, a forgotten artifact of human ambition reflecting sunlight like a mirror. The thought sends a little shiver through you. What if the mysterious visitor we're chasing is our own echo, a reminder of how far our machines have wandered? A quirky theory, sure, but stranger things have turned out true. Remember that crocodile dung sunscreen ancient Egyptians swore by? People laughed until they realised the mixture actually blocked ultraviolet light. Sometimes, the oddest hypotheses have a grain of reason hiding under the absurd. The hum of your fan grows rhythmic, almost like the pulse of data packets crossing interplanetary space. You realise that each pause between updates has its own suspense. The waiting becomes part of the story. Atlas is still racing toward perihelion, and Mars is still moving through its orbit, but the world down here is trapped in bureaucratic stasis. You smile at the cosmic contrast. The fastest traveller ever seen in the solar system meets the slowest paperwork on Earth. Somewhere, the universe must be laughing softly. The night drifts on. You make a small note in your journal. If Perseverance truly saw Atlas, it means we're no longer alone in observation. Two worlds are now watching the same traveller. You underline it twice, close the notebook, and let your thoughts drift beyond the dust storms, beyond the shutdown, to the faint light still crossing Mars's sky. The image repeats itself in your imagination, a single silver thread drawn against the black. No sound, no explanation, just motion. Maybe that's all the confirmation you need tonight. You wake to the soft rhythm of rain tapping the window, that almost Martian percussion of water you suddenly appreciate more now that you've been thinking about a world where it never falls. The news still hasn't changed. NASA's feeds remain blank, the official astronomy forum still wrapped in digital cobwebs. But the amateur channels are alive, buzzing like a beehive at dusk. Everyone is talking about the object, a TLAS, or 3I/Atlas, or whatever we're supposed to call it now. You open a new post titled "The Comet That Won't Behave," and the title alone feels like prophecy. You lean back, close your eyes, and let the story replay. It started like any other discovery. One of the ATLAS survey telescopes in Hawaii flagged a moving light back in July, its automated software identifying a standard comet candidate. Thousands of those alerts come through each year, most fading into the background of small body catalogues. But this one didn't fit. Its orbit was steep, its inclination strange, its path nearly aligned with the ecliptic plane. Even more suspicious, it was moving too fast. The initial calculations placed its inbound velocity at roughly 60 kilometers per second. You whisper the number aloud. It feels unreal, like trying to measure a dream in meters per second. On the forums, someone posted a diagram comparing its trajectory with Oumuamua's and 2I/Borisov's. The pattern is eerie. All three arrive from above the galactic plane, all three slicing through the solar system at speeds our local comets can't manage. Historians still argue whether Oumuamua was an icy shard or a thin solar sail fragment, and no one agrees whether Borisov was the rule or the exception. You can almost hear them sharpening their keyboards again for this new debate. But Atlas, or let's call it the comet that won't behave, seems even more mischievous. Its coma doesn't grow the way a comet's should. It doesn't form that flamboyant tail that stretches for millions of kilometers. Instead, it glows like a tight emerald knot, pulsing faintly, as though conserving energy for something. You sip coffee and scroll through the most recent images taken before conjunction. Fuzzy green spheres surrounded by scattered starlight, the anti-tail pointing toward the sun instead of away from it. That's not normal, one astrophotographer writes, and a dozen others reply exactly. A comet's tail forms when solar radiation pushes gas and dust outward, away from the star. For a tail to point toward the sun, some entirely different dynamic must be at play. Ionized particles, maybe, or electromagnetic effects. The problem is, you can't verify any of it while the big data servers sleep. The universe, it seems, picked the perfect moment to be confusing. You start reading about the ATLAS survey itself, named for the Asteroid Terrestrial Impact Last Alert System. built to detect potential impactors days before they reach Earth. The irony doesn't escape you. A system meant to save humanity from near-Earth rocks may have accidentally discovered something from interstellar space. You imagine the scientists who run those telescopes, coffee-stained shirts, blinking monitors, half-eaten snacks, realizing that one of their nightly blips isn't local. You picture that first moment of disbelief when orbital fits refuse to close. "It's on a hyperbolic path," someone must have whispered. "It's not coming back." The words echo in your head, "not coming back." There's a kind of poetry in an object that visits once and never returns, like a traveller brushing past our star just to remind us that the galaxy is bigger than our arguments. You find yourself feeling oddly protective of it, this misbehaving comet that refuses to play by our rules. Maybe it's tired of being categorized, filed away as debris or data. Maybe it wants to stay a mystery a little longer. Outside, the rain has stopped. The clouds are the same colour as Martian dust, and you smile at the coincidence. You think about how every major comet has carried its own personality. Halley with its punctual bravado, Shoemaker Levy 9 with its dramatic suicide into Jupiter, Borisov with its pure, icy innocence. But Atlas feels different, almost rebellious. Its refusal to grow a tail, its hyperbolic orbit, its green luminescence, each detail like a cosmic shrug. You wonder if the ancients would have given it a mythic name, something like the wanderer who doesn't obey. You scroll farther and find an obscure comment from a retired physicist in Belgium. He suggests the object could be a carbon-rich body whose surface crust has become electrically charged, repelling solar wind in complex patterns that create an illusion of a reverse tail. It sounds plausible, but then again, so did dozens of theories about Oumuamua before they collapsed under better math. Still, you jot it down in your notebook, because even the fringe deserves a seat at the table. Remember that time someone proposed that moonlight caused madness? Centuries later, we found out lunar brightness does influence melatonin production. Sometimes the fringe is just the frontier viewed from a weird angle. You take another sip and open an old paper about interstellar dynamics. The equations dance like hieroglyphs, filled with delta V's and perihelion distances. You don't need to solve them to understand the gist. For an object to be travelling this fast, it had to start far, far away, beyond the gravitational influence of any known star. Which means, statistically, there are countless others passing through right now, unseen. The universe is a highway, and we're sitting on a dimly lit exit ramp wondering why no one stops to talk. Your mind drifts to the way astronomers assign names. 3I stands for Third Interstellar, a sterile tag that still manages to sound romantic. The Atlas part, though, feels mythic. The Titan condemned to hold up the heavens. Maybe that's fitting. This little traveller is holding up the weight of our curiosity, forcing us to stare upward again. It's strange how easily wonder survives even the dull machinery of politics. Congress can shut down websites, but it can't shut down fascination. You glance at your notes from the last section, the streak in the Perseverance images, and add a small arrow. If this is the same object, then Mars just witnessed its first interstellar flyby. The thought makes you grin, half in disbelief. You picture Perseverance sitting in its crater, the object gliding overhead, both unaware that they've just made history together, a robot and a rock, meeting briefly in the vastness. The simplicity of it feels almost holy. As evening falls again, the sky outside your window clears. You step out for air, looking toward the invisible patch of sky where Mars hides behind the sun. Somewhere beyond that glare, ATLAS is still burning its quiet green, moving faster than any government response, older than any bureaucracy. You realise that by the time the shutdown ends, the comet will have already passed its closest point, leaving us only with images, arguments, and maybe a little humility. You whisper into the night, half-jokingly, "Behave, just this once." The universe naturally does not answer. You settle back into your chair and pull up the charts again, tracing the line of the wanderer through the black grid of the solar system. The numbers scroll in front of you like a lullaby of velocity and distance. 68 kilometers per second, perihelion, October 29th to 30th. The digits glow softly, hypnotic. You think about how familiar this all feels, how the community reacts, how speculation builds in layers like sediment. Historians still argue whether that first interstellar visitor, 1I/Oumuamua, was ever truly understood. It was supposed to be a comet, then an asteroid, then a light sail, and finally a cosmic shrug. Each theory arrived with elegant equations and left with embarrassed silence. The déjà vu makes you smile. New century, same wonder, same confusion. You imagine the astronomers of 2017 looking up from their keyboards as the discovery notice flashed across their screens. Back then the data poured in unhindered. No shutdowns, no frozen feeds, yet the mystery only deepened. Maybe uncertainty is part of the design, you think. Maybe the cosmos prefers half answers, so we'll keep watching. Oumuamua shot past at an impossible speed, tumbling like a chip of glass. They said it accelerated slightly without jets, as if pushed by light itself. Historians still argue whether that subtle acceleration was a measurement error or a clue to something engineered. You can almost hear the debates echoing across time, bouncing off the new data for ATLAS. You picture yourself explaining this to a friend who isn't a space nerd. You'd start simply, when an object comes from outside the solar system, its orbit isn't closed. It's a hyperbola, not a circle. It arrives once and then is gone forever. The friend would nod politely, but you'd see their eyes glaze over. You'd switch tactics. Imagine throwing a stone so hard it escapes the entire gravity of the sun. That's what Interstellar means. Then you'd pause, waiting for the weight of that sentence to sink in. The stone keeps flying forever. Atlas is one of those stones. The thought fills you with the same shiver you had when you first saw the rover's streak. Out there, beyond Mars, an object older than the solar system itself is gliding through our neighbourhood. Silent, swift, and maybe utterly indifferent. You remember how each interstellar object so far has carried its own personality. Oumuamua, the trickster. Borisov, the classicist. Now Atlas, the rebel. You wonder if there will ever be a fourth, or if the universe limits our introductions the way a dream limits memory. Across the forums, the arguments continue. Some call it Comet C/2025 P1, Atlas, nothing more. Others swear the trajectory is too perfect to be natural. Someone even overlays its inbound vector with the 1977 WOW signal direction and posts a breathless caption, only 9 degrees apart. You chuckle despite yourself. The internet has always been the world's biggest conspiracy telescope. Still, coincidence or not, that alignment is weirdly poetic. You imagine radio astronomers rolling their eyes even as they check the coordinates again, just to be sure. Outside, twilight spreads like diluted ink. You open your window and let the cool air mix with the faint hum of electronics. The fan's rhythm syncs with your heartbeat, a mechanical metronome to the night's speculation. You think about how, in every era, science and imagination have danced together in awkward partnership. During the Renaissance, people saw comets as omens. By the Enlightenment, they saw them as equations. Yet even now, with all our math, the old unease lingers. Maybe it's because comets move like thoughts, appearing suddenly, burning brightly, vanishing before we can capture them. You scroll to a paper by an orbital mechanics researcher who simulated ATLAS's approach using pre-shutdown data. His conclusion: the object's path is nearly coplanar with the solar system's plane, an orientation statistically unlikely for something truly interstellar. Historians still argue whether the same could have been said about Oumuamua's trajectory. Some claimed coincidence, others suspected cosmic steering. The debate feels less about numbers now and more about belief, about how comfortable we are admitting that we don't know. Your phone buzzes with a notification from an old astronomy chat. ESA confirms preliminary tracking through Mars Express instruments. You grin. At least someone's still watching. You imagine a small control room in Darmstadt, Germany, glowing with monitors. Engineers sip coffee, their screens filled with thin telemetry lines showing the spacecraft's gentle rotations. Somewhere in that stream, a faint signal from ATLAS hides. No grand revelation yet, just continuity. The thought comforts you more than any headline could. You take another sip of cold coffee, grimace, and decide it's a good metaphor. The cosmos serves its discoveries lukewarm, never when we expect them. You think about the shutdown again, how silence on Earth has become part of the data. If the servers had stayed live, we'd drown in updates, but now each rumour feels deliberate, each pixel precious. The universe has forced us into patience, and maybe patience is the only instrument delicate enough to handle mystery. You find yourself revisiting the 1970s, those golden years of Voyager and Pioneer. Back then, the public followed every transmission like a serial drama. Historians still argue whether that level of collective attention made people better scientists or just better dreamers. Either way, it kept the sky alive in conversation. Now, as funding debates mute official voices, you realise the conversation has moved here, to late-night watchers, to you and your quiet curiosity. The clock on your desk ticks softly. You jot in your notebook, 3I/Atlas, 3rd Interstellar, or just 3rd reminder that we don't control discovery. The words look smaller than the thought behind them. You glance out again. A break in the clouds reveals Mars, a dull ember near the horizon. Somewhere beyond it, invisible but real, the comet streaks on, dragging a ghost of green light through the black. You imagine what will happen when the feeds return. Press releases, tidy language, diagrams that tame the wildness into charts. The mystery will survive only in footnotes and archived live streams. But for now, while everything official sleeps, the story belongs to the night. You take a slow breath, the kind meant to settle you before sleep, and whisper, "Welcome back, traveller." We're watching, even in the dark. The hum of the fan answers softly, as if the universe is nodding off with you. The night deepens, and your room feels like mission control after everyone's gone home. Just the low glow of screens, the whisper of cooling metal, and the slow drift of your own thoughts through the static. You imagine rows of NASA terminals frozen mid-sentence, data streams cut off by bureaucracy. Somewhere a crawler script still tries to post an update, bumping into the same error line, 403, access denied during lapse of appropriations. It's an absurd phrase for something so cosmic. The universe keeps moving, and here we are, pausing because a spreadsheet didn't balance. You laugh quietly. If Mars could roll its eyes, it would. On one level, you understand how shutdowns work. The US government stalls, non-essential agencies pause, and essential functions, like planetary protection or life support monitoring, keep running. Missions don't die, they simply lose their voices. Data continues to pour down through the deep space network, a river no one is allowed to publicly acknowledge. It's like the cosmos has been placed under a gag order. Somewhere above Madrid, the big radio dish still listens for Perseverance's pings, but no one's posting them. You think of all those silent packets stacking up in a server room, waiting for the world to resume caring. You picture the engineers at home, their personal laptops open, half guilty as they peek at raw telemetry. You imagine one of them, let's call her Maya, sitting in a dim kitchen at 2 a.m, coffee in hand, scrolling through Perseverance logs that she technically isn't authorized to read right now. A single line catches her eye. Transient luminous trace, 942 LST. She knows what that means. She knows it could be 3I/Atlas, but she can't tweet about it, can't post, can't even call a press officer. She just sighs, saves the file, and whispers to the empty room, "Please don't disappear before Monday." The irony is almost artistic. While we shut ourselves down, Mars spins on. The sun throws another wave of charged particles. The interstellar object keeps racing closer to perihelion, and the universe politely ignores our paperwork. Historians still argue whether similar lapses in earlier decades cost us crucial observations, like the 1995 funding freeze that nearly delayed data from the Hubble servicing mission. If you listen closely, you can still hear that ghost of lost science humming through every new shutdown. It's the sound of what might have been. You open your browser and refresh NASA's homepage out of habit. The same banner appears. Due to a lapse in federal funding, most activities are suspended. Underneath it, the last update remains frozen in time, September 30th, a bright photo of the sun's corona, the caption cut off mid-sentence. You trace the date with your finger, thinking of how it already feels like an artifact. Maybe someday curators will display this very screenshot in a museum, evidence of how human progress once tripped over its own red tape. Outside, the neighbourhood sleeps. A distant siren fades into silence. You realise that the hush in your room mirrors the hush across the scientific world. When information stops flowing, imagination rushes in to fill the vacuum. That's why rumours about 3I/Atlas are multiplying. People need a story to tell while the data rests. Some claim it changed trajectory after the solar storm, others that its green glow has intensified, that maybe it's charging somehow. You smile at that word, charging, as though the cosmos were a giant battery warming up for disclosure. It's nonsense, of course, but harmless nonsense. Every culture, ancient or digital, invents myths to explain a paused sky. You glance again at the map you printed earlier. Mars gleams there like a copper coin, the dashed path of Atlas sweeping past it in a neat arc. You imagine being on the planet now, the thin atmosphere crackling faintly with static from the recent coronal mass ejection. The horizon would be tinted peach, the dust finer than powdered cinnamon. Somewhere in that haze, Perseverance's Mars camera points upward, capturing another series of exposures because that's what it was programmed to do. No politics, no hesitation. The thought comforts you. Machines keep their promises even when people can't. In the quiet, you remember another historical irony. During the 1969 Apollo 11 landing, one of the tracking stations in Spain almost lost power because local bureaucrats hadn't processed the electricity invoice. The engineer on duty paid the bill himself to keep the signal alive. Historians still argue whether that act of quiet rebellion saved the live broadcast of humanity's first steps on the moon. You like that story because it suggests that small, stubborn gestures can keep wonder alive. Maybe right now, another unsung engineer is doing the same, rerouting a data stream through a personal server, ensuring that Atlas's passage isn't lost to silence. You breathe deeply, imagining the hum of the deep space network stretching across 3 continents: Goldstone, Canberra, Madrid. The great antennas keep turning with the Earth, following signals from Mars as if nothing has happened. Their motors whir softly, the night air vibrates with microwaves. You picture those invisible threads of communication weaving through the void, holding our curiosity together. Even during a shutdown, the universe remains conversational. It's just that we've muted ourselves. Your eyes drift to the clock. It's nearly midnight again, and you can't decide whether to sleep or to stay up for ESA's next scheduled observation window. The Europeans are free from our bureaucratic storms, happily rotating their spacecraft toward Atlas. You envy them, but you also know that when the data finally re-emerges, the world will remember why curiosity doesn't belong to a single agency. You jot a note in your journal. Wonder is an essential service. The ink bleeds slightly into the paper, a tiny analogue echo of a digital truth. The rain starts again, a soft percussion like static from a distant transmitter. You close your eyes and imagine those servers coming back online one by one, like city lights flickering after a blackout. The data queue will be massive, millions of telemetry packets waiting to be decoded. Somewhere in that flood will be the clear signature of the object itself, maybe even a faint glint of its nucleus. Until then, silence is our instrument, patience our antenna. You stretch, feeling the weight of the day settle across your shoulders. The shutdown isn't the end of observation, it's the pause between breaths, the comma before the next discovery. Outside, the universe keeps speaking in light, and though we've temporarily unplugged our microphones, you swear you can still hear it if you listen hard enough. You wake before dawn, the world still blue and half dreaming. For a few minutes you lie there, listening to the refrigerator's hum like distant telemetry from Mars. The shutdown continues, 3rd day now, and the official channels remain blank. But somewhere out there, Perseverance is awake under its salmon sky, dutifully snapping another batch of exposures. You picture its lens fogged with dust, its solar panels glinting as morning frost evaporates. You imagine the rover tilting its mast upward again, searching for that faint line of light that crossed its vision the night before. There's something heartbreakingly human in that routine, a persistence we built into a machine to remind ourselves not to give up when the signals go quiet. In your mind, you can see the image sequence, 12 frames taken over 9 minutes, the stars dragging tiny vertical smears as Mars rotates beneath them. Each exposure catches a whisper of motion, a streak slicing diagonally through the pattern. It shouldn't be there. You picture data scientists on unpaid leave replaying those frames in secret, whispering over group chats. It's consistent across all exposures. The direction doesn't match orbital debris. You imagine one of them, maybe Maya again, pulling up the metadata, checking the orientation of the rover's Mars cam. The numbers line up perfectly with the projected approach of 3I/Atlas. Her pulse probably kicked up a notch right there. You roll the thought around in your head, a line in an image, 9 minutes of data, a possible interstellar visitor. That's all we have, and yet the mind rushes to fill the vacuum with narrative. You've seen it happen before. When Oumuamua was first tracked, The dataset was just as thin, and still it generated 1,000 papers, documentaries, and that best-selling book that declared, boldly, alien technology. Historians still argue whether that boldness helped science or just sold more streaming subscriptions. Either way, mystery has a way of funding itself. You step outside into the early light. The sky's a dull steel grey, but you tilt your head as if Mars might be there, hiding beyond the glare. You imagine standing beside Perseverance, your boots sinking slightly into red dust, the thin air rasping in your suit. The rover hums quietly at your side, its lens still fixed on that part of the sky where the object moved. You watch together as dawn spreads across Jezero crater. For a moment it almost feels like home. Back in your apartment you refresh an amateur astronomy thread where users are analysing the same data. Someone has stitched the frames into a short video. The streak glides across the screen like a white thread pulled through fabric. Another user runs a simulation of expected star motion from Mars and overlays it. The difference is obvious. Whatever moved across Perseverance's sky wasn't following Mars's rotation or any known satellite orbit. The comment section bursts into theories. One person insists it's a cosmic ray hit. Another says it's clearly 3i/Atlas. A third posts a tongue-in-cheek meme showing the rover accidentally photographing a flying saucer with the caption, "Oops, classified." You laugh, though you feel a twinge of envy for the Europeans who'll soon have real data. ESA's press team, still fully funded and caffeine-charged, posts a brief note confirming that both Mars Express and the Trace Gas Orbiter are now tracking the object. They don't call it Interstellar, just Cometary Candidate. But the words, high-velocity body of unusual spectral character, sneak into the bulletin, and that's enough to set every stargazer buzzing. You picture control rooms in Darmstadt and Paris, technicians adjusting antennas while outside the windows, dawn spills across Europe. There's something deeply satisfying about the idea of a continent quietly keeping watch while another sleeps. Your coffee has gone cold again, but you keep reading. One post links to a speculative model, suggesting that Atlas's green coloration isn't from diatomic carbon, the usual culprit, but from an overabundance of excited oxygen ions, something rarely seen in comets. If that's true, it implies the object's chemistry doesn't match anything from our neighbourhood. Historians still argue whether the same odd oxygen signatures in 2i/Borisov's tail were instrumental glitches or genuine evidence of alien chemistry. The debate feels familiar. Nature loves to imitate imagination. You start thinking about perspective. From Earth, the comet is invisible now, lost in solar glare, but from Mars, the geometry is perfect. The sun is a different shape there, smaller, more concentrated, and its light cuts the sky like a scalpel. Perseverance's camera, even filtered through dust, might capture things that would blind Earth's telescopes. You find it poetic that another planet has become our vantage point, our second pair of eyes. Humanity has extended its gaze so far that even when one world closes its lids, another stays awake. You scribble that thought down in your notebook. Mars is Earth's eyelid, blinking slower, seeing longer. It sounds pretentious, but you like it. Then you add, perseverance equals patience embodied. You grin at your own wordplay. Fatigue makes philosophers of us all. Another tab loads a thread comparing the brightness of the streak to estimated reflectivity. If the object truly measures 5 kilometers across, then its albedo, the measure of reflectivity, must be unusually high to appear that bright from Perseverance's location. That leads to a wilder idea. What if its surface isn't dusty but metallic? You pause, remembering the endless arguments about Oumuamua's shiny pancake-flat form. The possibility of a reflective interstellar object isn't new, but each time it resurfaces, hearts race. You can almost hear the late-night talk shows warming up their graphics. Alien probe over Mars? The world never changes, only the thumbnails get sharper. You lean back, stretching. The fan hums, the window fogs slightly. You think of all the people right now peering at the same frames, eyes red from staring at pixels. Somewhere a teenager in Poland probably just wrote the first line of a thesis on this very streak. Somewhere else, a retired amateur in Namibia is adjusting his homemade telescope, hoping to catch another glimpse. That network of quiet curiosity spans the planet, and suddenly the shutdown doesn't feel like silence anymore. It feels like distributed vigilance. You close your eyes and imagine the rover sending its next data burst. A radio pulse leaves Mars, travels across space, hits the Great Dish at Madrid, then bounces through fiber lines, routers, proxies. It may take days before it reaches public view, but the signal already exists. The story is already being written in photons. You whisper to yourself that patience is observation's hidden half, and the words sound truer than any headline. When you finally look at the clock, dawn has become full morning. The rain has stopped, and sunlight slides across your desk, scattering in a way that reminds you of dust tails and plasma comas. Somewhere out there, the object keeps flying, unbothered by funding debates or human impatience. Perseverance keeps photographing, and you keep waiting, listening to the soft mechanical rhythm of a universe that never really stops working, even when we pretend it does. You spend the morning drifting through a half-dozen European live streams, their accents and countdown timers merging into one long hum of competence. ESA hasn't missed a beat. Mars Express and the Trace Gas Orbiter both report normal telemetry, their solar panels catching the faint winter light over the red planet. Somewhere inside a control room in Darmstadt, rows of consoles glow with data scrolling in emerald code, and every few seconds you hear that familiar ping as a packet arrives from Mars. You imagine the engineers standing around the big display showing orbital tracks, one red line for Mars, another thin white curve for the visiting object. Every loop around the planet brings 3i/Atlas closer to its moment of alignment. You sip your coffee and listen to the voices on the feed, calm, matter-of-fact, with just a trace of excitement hiding under professional phrasing. We're acquiring signal from Mars Express, instruments in observation mode, optical payload stable. You smile. They make it sound so casual, as if pointing a camera across 30 million kilometers of space were just another Tuesday task. The irony doesn't escape you. While one half of the world argues about budgets, the other half quietly continues humanity's oldest hobby, staring at the sky. You picture the scene on Mars itself. The sky is tinted butterscotch, thin clouds of dust gliding slowly like ghosts. The two orbiters glide above that calm, their metallic skins glinting faintly as sunlight catches them. From their altitude, the object would appear as a pinprick racing through the black, its trajectory cutting cleanly across the Martian night side. Somewhere below, Perseverance rests in Jezero crater, still taking its own exposures. For the first time in history, two human machines on and around another planet are watching the same interstellar visitor. That thought feels monumental and intimate all at once. ESA posts a brief update. One paragraph, typically understated. Initial images confirm detection of transient object matching predicted coordinates. Further spectral analysis pending. The sentence lands in your chest like a drumbeat. You scroll the comments, watching the entire online world light up with speculation. Some insist it's just a comet, others whisper about alien tech again. You resist the urge to roll your eyes. Historians still argue whether that famous 1976 Viking photograph of a face on Mars was a case of overexposed lighting or humanity's need to see itself everywhere. The arguments never change, only the object of fascination does. You download the raw frame that ESA releases a few hours later. The resolution isn't great, just a blur of greenish light framed by the darkness of space, but your heart races anyway. There it is, Atlas, unmistakable, a tight knot of luminosity with no visible tail. You zoom in until the pixels break apart, the way ancient astronomers once strained their eyes at the eyepiece. You swear you can see subtle texture inside the glow, almost like concentric shells. Maybe it's artifact, maybe it's something real. You jot a note, possible layered coma structure. The phrase sounds technical enough to mask your wonder. Outside your window, clouds drift by, mirroring the slow swirl of dust around Mars. You lean back and think about how many people, right now, are staring at the same fuzzy blob from different corners of the planet. It's a quiet global ritual. No speeches, no anthems, just curiosity shared across time zones. ESA's feed plays faint background music, some ambient synth track meant to calm nerves. You laugh softly. If only they knew you were already half asleep with awe. A pop-up notification appears from a French astrophysicist's blog summarizing early spectra. Dominant emissions, CN and C2 bands, anomalous oxygen line at 557 nanometers. You translate that automatically in your head. Cyanogen, diatomic carbon, and the same mysterious green oxygen signal everyone's buzzing about. It's the kind of chemistry that belongs to comets, yes, but the intensity ratios are off. Historians still argue whether the green line in early comet observations was purely chemical or partly electrical, a product of plasma interactions. The debate just found a new chapter. You click to another tab where ESA's mission director is giving an interview. She smiles politely, eyes half hidden behind tired glasses. "We can confirm we're observing a very active object," she says. "We will not comment on its interstellar origin until further orbital refinement." Translation: they know it's weird but refuse to say so yet. You admire that restraint. Science, after all, is built on patience. But the fan communities explode anyway. The word active becomes anomalous within an hour, then artificial by evening. The telephone game of wonder never fails. You stretch and walk to the window. The afternoon light has turned golden, and for a moment you imagine that glow stretching all the way to Mars, a line of sunlight connecting you to the orbiters now whirring above the red world. Somewhere in that line, photons from Atlas are scattering into sensors, bouncing into data packets, travelling across the void. The idea feels strangely intimate, as though the comet were whispering through machinery straight into your room. You sit again, open your notebook and sketch a rough diagram of the orbits. The geometry fascinates you, how something born between stars can glide so neatly through the clockwork of our system. It passes within whispering distance of Mars, threads the ecliptic like a needle, and then vanishes forever. It's like a cosmic guest who knows the etiquette of not overstaying. You write underneath the sketch, "Wonder is temporary, but precision is eternal." Evening creeps in. The shutdown back home shows no sign of ending, but you barely notice now. The world feels connected again through Europe's signal. In a quiet way, the cosmos has overridden politics. You think of the engineers adjusting lenses, the scientists waiting for spectra, the countless amateurs stacking images through the night. You think of the Martian orbiters catching the faint glimmer of an interstellar traveller while the Earth sleeps, and you realise that discovery isn't a single nation's heartbeat, it's a planetary pulse. You close your eyes, imagining the orbiters' cameras cooling after a long session, their data buffers full of light from another star's debris. Somewhere inside those images lies a secret we're not ready for yet. You whisper a thank you to the silence that made room for other voices, then breathe in the quiet hum of your room, content to wait for dawn and whatever new pixels tomorrow might bring. The day breaks soft and grey, the kind of morning when the world feels made of static. Your coffee steams against the window while you scroll through the latest overnight uploads. The ESA servers have been busy. 4 new images from Namibia, taken just before the comet slipped too near the sun's glare. Each one shows that impossible emerald hue again, shimmering faintly against the desert's black sky. You pause at the photographer's note. Exposure 90 seconds, telescope cooled, humidity low, object unusually stable. The simplicity of it makes you smile. Even in the age of orbiters, it still takes a single human in a remote place to remind the cosmos we're watching. You lean closer, enlarging the frame until it fills your screen. The object glows like sea glass, soft at the edges yet bright in its core. Around it, stars stretch into clean points. There's that odd sunward anti-tail, a luminous brushstroke pointing in the wrong direction. You whisper, "You're not supposed to do that." The words fog the glass in front of you. Somewhere in your mind, 1,000 textbooks shuffle nervously. A comet's dust tail always points away from the sun. That's the rule, one of the few celestial behaviours humans have actually mastered. But Atlas seems allergic to rules. You picture the Namibian sky the night that photo was taken. Dry wind sweeping over ancient dunes, telescopes humming softly. The observer, Gerald Raymond, probably stood there with a thermos of coffee, glancing between the eyepiece and the digital readout. When he processed the image later, maybe he leaned back in his chair and whispered the same thing you just did. "This isn't right." You imagine him posting the file online, watching it ripple across the community like an electrical current. Within hours, astrophotographers in Chile, Spain and Japan would stack their own images, each confirming the anomaly. The data became a shared heartbeat across continents. You open a new article explaining how the green glow likely comes from CN and C2 molecules fluorescing under solar radiation. That part is textbook. But the anti-tail, no one agrees. Some claim it's a perspective effect, Earth's position relative to Mars and the Sun tricking the geometry. Others think the comet's ionized gas might be responding to a magnetic twist in the solar wind, forming a reversed streamer. Historians still argue whether similar oddities in 1957's comet and Roland were physics or illusion. The debates loop back and forth like celestial echoes, proving once again that certainty is rarer than starlight. You rest your chin on your hands and watch the glow on your screen. The object looks alive. You think of those ancient cultures that gave comets temperaments, tricksters, messengers, portents. Maybe they weren't entirely wrong. Maybe the universe really does have moods, expressed through plasma and dust. A soft laugh escapes you. The sound feels too loud in the quiet room. Outside, traffic murmurs faintly, an earthly rhythm beneath your cosmic daydream. The article scrolls on, quoting new estimates. The coma spans hundreds of thousands of kilometers, a sphere of gas larger than the sun's diameter if seen edge to edge. You blink, trying to imagine something that vast surrounding a nucleus no bigger than a mountain. It's like an ant dragging an atmosphere behind it. The text mentions that the coma might grow even more as the object nears perihelion. You picture it swelling like a bubble, thin and iridescent, drifting through the inner solar system. If you were standing on Mars now, you might actually see the sky faintly green at night. The thought gives you goosebumps. You click another tab showing a time-lapse of those same Namibian frames. The comet seems to pulse every few seconds, brightening, fading, brightening again. It could be atmospheric distortion, or it could be Atlas itself breathing. The rational part of your brain says it's just data fluctuation. The tired, romantic part whispers, what if it's talking? You chuckle at yourself. Too many late nights will make anyone poetic. Still, you jot a note. Brightness modulation period approximately 5 seconds. Check against solar wind data. It's probably nothing, but the act of writing it feels like planting a seed. Outside, sunlight finally cuts through the clouds, a sharp golden ray that makes the dust on your desk glow. You squint, thinking of that same light hitting the comet's surface. How much energy does it take to make a world shine green? The calculations run through your head automatically. Albedo, emissivity, ion density, and you give up halfway. The math can wait. Right now, wonder feels like enough. A message pops up in your feed. ESA confirms successful imaging sequence complete. Data downlink scheduled tonight. You grin. The orbiters have done their job. Mars Express, that aging veteran, still manages to deliver miracles. You imagine it spinning gracefully, its cameras cooling after hours of exposure. Somewhere inside its memory banks, new portraits of Atlas wait to be decoded. It's strange how personal it feels, as if a friend just texted you a secret photo from another planet. You close your eyes for a moment and imagine the scene as a painting. The Namib Desert under a velvet sky, the comet glowing green above the dunes. Millions of kilometers away, Mars lit by the same ghostly hue, and between them, a network of satellites catching photons like snowflakes. The composition is too perfect to be coincidence. Then again, you remind yourself, humans are excellent at inventing patterns. Maybe that's what discovery really is, the universe feeding us randomness and watching us weave it into meaning. Your phone buzzes again, a notification from a science journalist in London. Historians still argue whether the anti-tale of and Roland changed comet science forever, or was just camera glare. Maybe we'll find out tonight. You smile, appreciating the circular poetry of that sentence. Centuries of progress, and we're still arguing over the direction of dust. You glance at the clock. Just past noon on Earth, midnight on Mars. Perseverance should be asleep, its heaters gently cycling. The red horizon empty except for that faint smudge racing through the void. You imagine it dreaming, if machines can dream, of green ghosts and shutter clicks. The thought soothes you. You reach to dim your monitor, the image shrinking to a single dot before vanishing into black. Somewhere out there, the real dot keeps moving, fast and silent, indifferent to human metaphors. You whisper goodnight to it anyway. By the time evening folds itself around your window again, the news cycle has caught up. Even the larger networks are awake now, their anchors reading from teleprompters with that trademark mix of calm and bewilderment. A powerful solar eruption earlier this month may have interacted with the object known as 3I/Atlas, one says. His eyebrows raise just enough to suggest cosmic scandal. You mute the television and let the images play silently. Stock footage of the sun, arcs of plasma leaping like molten ribbons. The truth, as always, is stranger and subtler than television can handle. You scroll through the European Space Agency's updates instead, tracing timelines between the coronal mass ejection of September 25th and the photographs that followed. You remember that eruption. The sun had looked furious even in backyard telescopes. It hurled billions of tons of charged particles into space, a halo of fire moving faster than any human-made probe. Some of those particles would have brushed Mars days later, washing the thin atmosphere in auroral light. Somewhere in that same flow of solar wind, Atlas drifted, an uninvited guest in a storm. The idea fascinates you, the universe's weather system brushing against an object from another star. Historians still argue whether similar solar tempests once shaped the tails of ancient comets into the awe-inspiring fans recorded by Chinese astronomers in 1059. Maybe this is the same story told again, but in higher resolution. You read an ESA memo describing the possible effects. The solar blast might have stripped part of the comet's outer shell, exposing fresh material beneath. That could explain the intensified green hue and the faint pulse noticed in the Namibian frames. It's a living chemistry experiment, a frozen relic waking up under the sun's interrogation. You find the idea oddly comforting. Renewal through chaos, rebirth by radiation. Maybe that's a universal law. Outside, thunder grumbles across your own sky. You glance up, half expecting to see auroras. The storm here feels almost sympathetic, as if Earth itself is echoing the sun's tantrum. You imagine Atlas spinning within that plasma wind, its dust grains tearing loose, its gases ionizing into sheets of light. Somewhere, Perseverance's instruments might even be picking up electromagnetic noise, tiny oscillations in Mars's upper atmosphere whispering the story of an interstellar visitor brushing against solar breath. You write that phrase down, solar breath, because it sounds like a poem waiting for science to confirm it. A ping draws your attention, a new post from ESA's spectroscopy team. They've detected rapid changes in the object's brightness and spectral composition over several days. The green emission lines are intensifying, but so is an ultraviolet signature that doesn't fit ordinary comet models. Historians still argue whether unusual UV signatures in early comet spectra indicated organic compounds or instrumental error, the report says dryly, quoting its own footnote. You chuckle. Even bureaucracy has its poetic streaks. You picture the interstellar object tumbling slowly, surface cracking, releasing gases that have been trapped since before the sun existed. The thought makes you dizzy. Every molecule escaping that core is older than Earth, older than life itself. If someone could bottle that vapor, it would be the scent of the galaxy's childhood. For a moment you close your eyes and imagine the smell. Ozone and frost, iron dust and forgotten sunlight. The room feels bigger for it. The rain outside intensifies. You lean closer to your monitor, watching animations of magnetic field lines twisting around the comet like ribbons around a dancer. A researcher in Prague suggests that the object's reverse tail might have been sculpted by this storm, its ions funneled backward by an unusual pocket of magnetic reversal. It sounds plausible, even elegant. Another scientist counters, no, the orientation is intrinsic, an artifact of interstellar origin. The debate unrolls like a celestial courtroom drama, citations flying faster than solar particles. You take a break and glance at an old astronomy book on your shelf. Its yellowed pages show woodcut drawings of comets with blazing swords for tails, drawn by medieval monks who thought they heralded plagues. You smile at their innocence, yet part of you wonders if they also felt this same unease, the shiver that comes from knowing the sky can change overnight. Back then, comets were omens. Now they're datasets. The difference is mostly vocabulary. A lightning flash brightens your room for a heartbeat, casting the coffee mug's shadow long across the desk. You wonder if Mars too has its own lightning tonight, perhaps small electric discharges flickering through dust storms stirred by the same solar gust that hit Atlas. The idea of shared weather between worlds feels oddly intimate, like two planets breathing in rhythm. You picture the red planet's horizon glowing faintly green as solar particles dance across its atmosphere. If someone stood there, they might see both the aurora and the interstellar traveller at once, a private light show for an audience of none. The next message in your feed comes from a physicist you follow on social media. Ion density spike, observed at 0.3 astronomical units. If that corresponds with Atlas's trajectory, we may be witnessing its coma expanding post-CME. You grin, the way you do when the universe offers both a mystery and a breadcrumb. Somewhere in that statement lies the story of how starlight shapes visitors from beyond. You pause the endless scrolling and look outside again. The rain has slowed to a drizzle, each droplet a miniature lens distorting the streetlights. You imagine those droplets as tiny comets, each carrying its own microcosm of dust and reflection. The boundary between your world and space feels thinner tonight. You realize how easily cosmic and domestic merge, the hiss of rain mimicking static from solar storms, your heartbeat syncing with the rhythms of distant plasma. You take a slow breath and return to the monitor. The latest ESA note concludes with cautious optimism. Further observations required to determine if the CME has altered Atlas's trajectory or composition. Translation. We don't know yet, but we will. That promise is enough. You close the tab and let the room go dark except for the pulsing glow of the screensaver. A slow, shifting spiral of light. It looks almost like a coronal loop, and for a moment you pretend you're seeing the sun breathe. In the quiet that follows, you whisper to no one, "Keep moving, traveller. The storm's behind you now. Somewhere beyond Mars, maybe it hears you." The rain ends sometime before dawn, leaving the world washed and fragile. You wake to a strange calm, the kind that comes after long noise. Outside, the streets glisten like the surface of another planet. You brew your coffee and flip open your notebook. The last thing you wrote before sleep was solar breath. The words look cryptic in the morning light, but they still feel right. The sun breathes, and everything in the solar system, planets, spacecraft, people, is just dust drifting through its exhale. Somewhere in that endless exhalation, the interstellar wanderer continues its slide toward the inner regions. You open your feeds, the forums have transformed overnight. What had been measured discussion about CME data has bloomed into a wild garden of speculation. There are side-by-side comparisons of Atlas and the WOW signal coordinates again, colour-coded infographics claiming perfect alignment, and a handful of blurry YouTube thumbnails promising alien technology near Mars in letters the size of moons. You laugh softly into your cup. Humanity has a rhythm. Find a mystery, light a candle, start a rumour, then call it revelation. Historians still argue whether the first radio transmission from Arecibo in 1974 caused more scientific progress or more conspiracy newsletters. The pattern hasn't changed in half a century. You scroll through a few of the better analyses. One argues that Atlas's smooth light curve indicates a large solid object, rather than a typical dusty nucleus. Another claims the opposite, that the lack of variability means the surface is coated in vaporized gases, hiding any rotation. The only thing everyone agrees on is that it's strange. Someone posts a joke. Plot twist. It's a lost Mars probe coming home. The humour helps. It keeps the awe manageable. Still, you feel that itch of curiosity turn electric. You close your eyes and imagine what the object actually looks like. Not the pixelated blur on your screen, but the real thing. A green, glowing shard cutting through space at 60 kilometers per second. Maybe its surface is smooth and metallic, maybe fractured like a broken mirror. You picture sunlight scattering off it, each photon deflected like a question unanswered. There's a kind of beauty in ignorance, the way not knowing keeps wonder alive. You pull up another ESA update. The headline reads, "Trace gas orbiter confirms non-gravitational acceleration." You sit up straighter. The text explains that Atlas's motion deviates slightly from pure gravity-based predictions, as though some subtle force were nudging it. That phrase triggers déjà vu. It's the same anomaly that haunted Oumuamua years ago, the same whisper that made everyone briefly consider alien propulsion. The scientists, cautious as ever, list natural explanations first: outgassing, solar radiation pressure, uneven heating. Still, your pulse quickens. Historians still argue whether Oumuamua's acceleration was miscalculated or misinterpreted, whether it was dust, ice, or design. Now the debate has a sequel. You type a note in your log, Atlas. A new push begins. You pause and add, if it accelerates near perihelion, that's the real test. It feels almost sacrilegious, trying to pin mystery down with math, but that's what science is, a structured act of curiosity. You imagine the researchers at ESA, their screens filled with columns of decimals, plotting tiny changes in velocity, every data point another heartbeat from deep space. A new thread pops up from an amateur astronomer in Chile who caught a faint radio signal while tracking Atlas's coordinates. He claims it's structured noise, not a transmission, just an unexpected pattern in background static. Others quickly debunk it, pointing out atmospheric interference from a passing satellite. But you linger on the phrase structured noise. It sounds like a metaphor for human perception. We can't stand randomness, so we polish it into meaning. Maybe that's what all astronomy is, sculpting order out of cosmic static. You glance at your reflection in the dark window. Your face looks ghostly in the monitor's green glow. Behind it, dawn is rising. You imagine looking out from Mars right now. The sky there would be pale orange, the sun sharp and white. Somewhere above that horizon, the visitor streaks by, a dot against infinity. If Perseverance's cameras turn just the right way, they might capture a few more frames before the sky brightens. You find yourself hoping they do, even if you won't see them until the shutdown lifts. You stretch, walk to the window, and breathe the cold morning air. A gull passes overhead, its wings catching sunlight like solar panels. You grin. Earth is full of small analogies if you pay attention. When you sit again, your feed has updated. Someone has traced Atlas's path backward through the galaxy, using a simulation of local stellar motions. The model suggests it came from near the constellation Sagittarius, from a region rich in old stars and molecular clouds. That means it might carry material from before the Milky Way's spiral arms were even fully formed. You feel that familiar shiver, the sense of standing next to deep time. You pour a second cup of coffee and keep reading. Another post argues that the object's speed, 68 kilometers per second at perihelion, is too high to belong to any gravitationally bound body in the local neighbourhood. In simpler words, it's definitely from somewhere else. You let that sink in. A piece of another solar system, possibly another sun entirely, is now brushing past Mars. The odds of any two civilizations sharing that exact moment are infinitesimal. Yet here you are, watching it happen through a screen that still smells faintly of rain. A soft ping from your phone reminds you that your daily work emails remain suspended. Everyone's furloughed, waiting for politics to reboot. You ignore it and stay with the cosmic story instead. The shutdown feels distant now, irrelevant. Discovery doesn't pause for paperwork. It happens in the cracks, in the spaces between official statements. Maybe that's the secret reason we keep looking up, to remind ourselves that the universe never asks for permission. As the morning brightens, you close your eyes and imagine Atlas moving silently through solar light. Around it, plasma ripples. Behind it, the faint wake of its passing curls like vapor on a river. Somewhere, signals from orbiters are still travelling toward Earth, carrying data that no one can yet process. For now, only the universe knows what it truly is. You whisper into the quiet room, half in jest, half in prayer. Keep your secrets a little longer, friend. We'll earn them eventually. The day unfolds slowly, the kind of muted afternoon when time feels syrup thick. You've spent so many hours watching screens that your eyes buzz, but the hum of discovery refuses to let you rest. The global feeds are alive now. ESA's clean graphics, the Chinese agency's terse bulletins, the UAE's bright social posts written in soft Arabic English poetry. One headline catches your attention. Collaborative Observation Initiative. 3 nations target object A, TLAS. You exhale in disbelief. For once, everyone seems to be watching the same thing. It's as if the cosmos has quietly stitched together what politics keeps pulling apart. You start with ESA's data. Their orbiter confirmed non-gravitational acceleration again, but this time with a sharper measurement. Then you switch to the Chinese mission log. Short sentences translated from Mandarin, each one humming with restrained pride. Tianwen-1 orbiter, retargeted cameras. Successful spectral sweep of unknown object. Data transmission stable. The attached image is tiny, but it's beautiful in its clarity. A glowing green core with faint symmetrical halos around it. You stare at it for a long time, aware that the light on your screen left Mars more than 15 minutes ago, that photons from another world are now bouncing through your room. You scroll farther. The UAE's Hope probe has joined the campaign, its instruments tuned for ultraviolet emissions. Their press note is simple, almost poetic. We look to the traveller that looks to us. You grin. Even bureaucracy can sound lyrical when the sky cooperates. Somewhere, 3 space agencies, European, Chinese, Emirati, are all gathering light from the same wanderer while NASA's official sites remain asleep. You can almost feel the irony radiating from the servers, yet there's comfort in the redundancy. The universe is too large to be left to one nation's budget. You close your eyes and picture the 3 orbiters circling Mars like attentive guardians, their cameras blinking in unison. Below them, the planet turns slowly, deserts gleaming, craters shadowed. Each probe is separated by thousands of kilometers, yet united by a single goal: capture every possible photon from the interstellar visitor before it slips away. You can almost see their paths intersecting like threads in a cosmic loom, weaving together a global tapestry of data. An ESA engineer posts a photo from the control room, rows of tired faces glowing in monitor light. The caption reads, "Still awake, still watching." You feel a lump in your throat. It's easy to forget how much of science is made of sleepless humans chasing silent signals. You remember reading about the 1986 Halley's Comet campaign, when dozens of international probes coordinated for the first time in history. Historians still argue whether that was the true birth of global space science or merely a coincidence of timing. Either way, tonight feels like an echo of that cooperation, updated for a new century. You take a sip of water and imagine the data streaming in. Raw counts, spectral lines, velocity curves. Somewhere, algorithms are crunching them into patterns, trying to translate photons into meaning. If all goes well, by tomorrow the first composite image will be released. You picture what it might show, perhaps layers within the coma, rings of dust, or even faint jets venting gas. Yet part of you hopes it shows nothing ordinary at all. On one of the Chinese feeds, a young mission scientist gives a short statement. "We approach this phenomenon with humility," he says. "If it is interstellar, it is the first object we and Mars have seen together." His voice trembles just slightly. You like that? Science should tremble sometimes. It keeps the ego in check. You scroll to a commentary thread translating that statement into 20 languages. Each comment feels like a small candle lit in curiosity. A woman from Kenya writes, "Mars belongs to all of us now." A teenager in Brazil replies, "And maybe this visitor too." You smile, thinking how the internet, when it's not a chaos machine, can still resemble the best parts of a classroom. Evening creeps in again. You walk outside, needing fresh air. The city lights blink below thick clouds, and you imagine each one as a probe orbiting Mars. Somewhere out there, those real machines glide through the darkness, sending home evidence of a story unfolding 30 million kilometers away. You tilt your head toward the hidden sky and whisper, "Keep the data safe." The phrase sounds ridiculous, but it makes you feel connected, as if your voice might travel along the same radio channels. When you return inside, new images have already begun circulating. The combined dataset shows Atlas from multiple angles. The object's coma looks asymmetrical, denser on one side, faint arcs curling behind it like ripples in water. One researcher describes it as a shell structure reminiscent of magnetotail oscillation. You don't need to understand the physics to feel the wonder. Whatever this thing is, it's alive in motion, sculpted by forces older than language. You open your notebook and write, "Mars orbiters equals chorus, Atlas equals soloist." It's a silly metaphor, but it fits. Each spacecraft adds its harmony to the symphony of observation, and you, sitting in a dim apartment on a spinning blue planet, are the audience. For a moment you forget the shutdown, the politics, the speculation. There is only soundless cooperation across space. You think of the future historians who will write about this night. They'll have the advantage of hindsight, the full dataset, the clarity of distance. Historians still argue whether the first photographic plates of Halley's Comet contained hidden details missed for decades. Surely they'll debate this too. Maybe they'll marvel that during a time of earthly division, humanity looked up together. Or maybe they'll laugh at how we turned even interstellar mysteries into clickbait. Either way, they'll have the record. The hour grows late. You close your screens one by one until the room is lit only by the small green LED of your modem. A single dot, steady and patient. You think of the same colour glowing around Atlas, of the same pulse crossing space at the speed of light. 2 tiny lights separated by millions of kilometres, both refusing to flicker out. You let the sight lull you into a quiet trance, and when you finally whisper goodnight, it feels like you're saying it to the entire solar system. Sleep comes late and shallow. When you wake, The sky outside has the flat brightness of a winter noon, and your first thought is of Mars. You pull the laptop closer before you even reach for coffee. The ESA servers have pushed out a new data dump overnight. Hundreds of raw images, light curves, spectrograms, and a few translated excerpts from their joint sessions with the Chinese and Emirati teams. The file name headers scroll like poetry. MEXP_2025_10-07_Atlas_VIS003.fits, each one a tiny promise of discovery. You exhale slowly, feeling that familiar thrill of curiosity sharpen into focus. You open the first processed composite. The image shows the object's coma spreading outward like smoke trapped under glass. What stops you is the emptiness beyond it. There's no tail, not even a wisp. It's as if someone erased it with a cosmic brush. You tilt the screen and squint, but there's nothing. A comet with no tail, like a kite that's forgotten how to fly. The scientists on the message boards are already arguing about it. Some claim it's simply orientation. The tail pointed directly toward or away from the cameras, rendering it invisible. Others insist the material streaming from the nucleus has too little mass to form a visible plume. Either way, the phrase, "the long tail that isn't there," trends across every astronomy feed by afternoon. You click through more data. One image from the Tianwen-1 orbiter shows faint ripples, maybe plasma waves, curling from the object's sunward side. The brightness fluctuates in tidy rhythmic intervals. Someone posts a graph of the pattern. It looks suspiciously like a heartbeat. The forum jokes arrive instantly. The comet is alive, but behind the humour sits a sliver of awe. The rhythm is real, the mechanism unknown. Historians still argue whether similar pulsations observed in 1996's comet Hyakutake were instrumental interference or actual plasma oscillations. Perhaps 3I/Atlas has just reopened that debate. You lean back, rubbing your temples. The more you read, the stranger it gets. Without its tail, the object appears almost spherical, wrapped in layered shells that glow differently in infrared. The ESA team describes the structure as multiphase, suggesting zones of temperature and composition like an onion of ionized gases. You imagine peeling it back layer by layer, each shell revealing another era of the galaxy's history. Inside might be dust from a forgotten star, or the remains of something more deliberate. The idea makes your skin prickle, and you quickly chase it away with reason. You check a live-stream discussion from the Royal Astronomical Society. Grey-haired scientists talking softly over tea, their voices steady but eyes bright. It refuses classification, one says, adjusting his glasses. Not a typical comet, not quite an asteroid, certainly not inert. Another adds, "We may need a new category altogether." You smile. Science is at its best when it admits confusion. The debate reminds you of how astronomers once invented the term planetesimal, just to avoid embarrassment while arguing about Pluto. Maybe interstellar transient will be this century's linguistic bandage. The next feed you open is from the Chinese team's press translator. The object appears reactive to solar energy, but does not shed mass in expected fashion, the statement reads. We hypothesize electromagnetic containment within the coma structure. Containment, an intriguing word. You picture magnetic fields wrapping around the object like invisible ribs, holding its gases in check. Could that explain the lack of a tail? Could the coronal storm have magnetized it? The theory is bold, almost cinematic, yet oddly plausible. You scribble containment bubble hypothesis in your notebook and underline it twice. Outside, the light has changed. Clouds move fast across the sky, their undersides glowing silver. You step to the window, imagining how Mars must look under its own clouds now, the orbiters gliding overhead, their sensors pointed at a faint green spark. The planet probably has no idea it's part of history. The thought makes you smile again. Back at the desk, a notification pings from an ESA spokesperson. Joint release of multispectral imagery scheduled for 1900 UTC. You set an alarm. Until then, the speculation will only grow louder. Already, amateur analysts are comparing the object's lack of tail to that of 1I/Oumuamua, arguing both might share composition or origin. Others are chasing wilder paths. Some claim the magnetic shell implies artificiality, a design to preserve the object's structure against solar wind. You sigh, recognizing the inevitability of such leaps. Humanity cannot resist the narrative of intention. Yet even as you dismiss it, you feel a small tug of excitement at the thought. When the release finally begins, you watch the live stream with the reverence of a ceremony. A panel of scientists appears in front of the ESA logo, their faces pale from exhaustion. One by one, they present the colour-processed frames. The images are astonishing. A glowing sphere with concentric gradients of green and violet, surrounded by a faint electric haze. The central brightness is offset slightly, implying rotation or internal turbulence. No tail appears, only a subtle trail of charged particles spiralling inward toward the sun instead of away. The moderator clears her throat before speaking. These findings challenge our current understanding of cometary physics, she says carefully. The morphology is, in a word, anomalous. You feel goosebumps rise along your arms. The word anomalous carries the weight of both caution and wonder. It's the scientific equivalent of, we have no idea what's happening. You glance at the chat scrolling beside the stream. Thousands of viewers, thousands of exclamation marks. For once, global attention isn't on scandal or war, but on a green light near Mars. You whisper, "That's the real miracle," and jot it down before you forget. After the broadcast ends, you linger on the frozen frame of the comet. The silence in your apartment hums. The lack of a tail somehow makes the object feel lonelier, as if it carries its own gravity of secrecy. You wonder whether future missions will chase it, or if it will vanish beyond Jupiter before anyone can follow. Either way, you realize Atlas has already succeeded in its mission, whatever that was, by making you and millions of others look up again. The clock ticks toward midnight. The hum of your fan blends with the imagined whir of orbiters around Mars. You close your eyes, seeing green light flicker behind your eyelids. A tailless comet, a globe of contained fire, a question that refuses to end. Maybe that's all Discovery ever is. One bright question crossing the night. Night again, though it hardly feels like time has moved at all. You've lost track of days, orbiting the same screens, following the same green ghost through the digital cosmos. Tonight's data drop arrives right on schedule, compressed telemetry, position logs, and a short note from ESA confirming the object's closest approach to Mars. They call it a nominal passage. You grin at the understatement. After weeks of speculation and sleepless tracking, the greatest interstellar event in decades is summarized in 2 words that sound like a weather report. But scientists know better than to tempt the universe with adjectives. You open the position plots and trace the trajectory. The faint line curves gracefully past the planet, dipping just inside 0.2 astronomical units. If scaled down to human distance, it's the difference between a whisper and a handshake. No impact, no drama, just 2 worlds passing in silence. Still, you can't help picturing it in cinematic terms. The red planet gleaming beneath, Atlas sweeping by like a luminous arrow. The orbiters must have seen it in their instruments, perhaps even with their cameras, one world observing another as a visitor drifts between them. There's poetry hidden in orbital mechanics. You scroll through an ESA blog update describing Mars's environment during the flyby. Solar particles from the recent storm are still thinning out, and the planet's magnetic field, faint though it is, has been shimmering with unusual auroral activity. Instruments aboard the trace gas orbiter recorded bursts of ultraviolet emissions in the upper atmosphere, brief but synchronized with Atlas's passing. Historians still argue whether similar events during Comet Siding Spring's 2014 flyby were direct interactions or coincidental. Either way, the timing here is suspiciously elegant. You imagine standing on the Martian surface under that sky. The air would be thin and cold, but you might see faint ribbons of green light curling near the poles, their colour matching the visitor zone. Maybe the rover's sensors even registered the electromagnetic hum of the moment, a subtle change in the static of the dusty air. You like to think the planet noticed that for one breath of cosmic time Mars looked up. The press release is careful. No measurable atmospheric disturbance detected. Electromagnetic fluctuations remain under analysis. Scientists can't say magic happened, even when it kind of did. You lean back, picturing the same phrase written centuries ago about something else. Galileo noting nothing unusual after seeing Jupiter's moons, unaware he'd just redrawn humanity's map of heaven. Maybe understatement is our species' defense mechanism against awe. A new amateur image pops up on your feed, processed from raw data scraped off ESA's archive. It shows a faint glow trailing behind Mars's limb, like an afterimage. The caption reads, "Possible interaction plume?" The scientist will dismiss it as sensor noise, but you stare at it for a long time anyway. It looks like breath. The idea that Mars itself might have exhaled light as Atlas swept by gives you chills. You add it to your notes with a small smile, Mars under a passing shadow. You make yourself step away from the screens long enough to refill your mug. The night outside your window feels ordinary, yet you can't shake the sense that something profound just occurred, somewhere you'll never stand. Maybe that's why people invented rituals, to mark moments they couldn't directly witness. You lift your mug toward the sky and whisper a toast to the red planet and the traveller. It's ridiculous and sentimental, but it helps. Back at the desk, the data chatter has slowed. The orbiters are already turning back to regular duties, their high-gain antennas pointing home. Atlas continues its flight toward the inner system, unbothered by all the attention. You check a projection of its next path. By month's end, it will pass within sight of Venus, then curve toward perihelion before slingshotting outward again. By spring, it will be gone, a myth with coordinates. You think of all the temporary things humans have built around it, hashtags, headlines, late-night theories, and how quickly they'll fade. The comet, or whatever it is, will continue on, leaving us with nothing but traces. You scroll one last time through the joint logs. A short note from the Chinese mission reads, "Electromagnetic readings stable. No debris detected." The UAE team adds, "Spectral consistency confirmed." In other words, nothing exploded, nothing burned, nothing broke. The visitor came and went without incident. It feels almost like good manners. You can almost hear the planet sigh in relief. The comet threads, of course, tell a different story. Half the internet now insists the object transmitted something during the flyby. Tiny radio bursts mistaken for cosmic background noise. Others claim the absence of a tail proves deliberate control, a drive system disguised as magnetism. You don't argue, let them dream. Humanity has always needed its myths. What matters to you is the simplicity, a silent encounter between two strangers under the same star. You dim the lights and open the ESA livestream again. The feed shows a slow rotation of Mars as captured by the orbiter, its atmosphere faintly glowing at the poles. For a heartbeat, a green shimmer appears, residual data, maybe an artifact. But you take it as a farewell wave. You imagine Perseverance still sitting in Jezero crater, its sensors cooling after the long night, the faint hum of wind the only applause. You jot one last note before closing your notebook. Closest approach achieved, no catastrophe, no explanation. Just beauty. The simplicity feels right. The world loves noise, but sometimes the universe whispers instead. You let the thought settle as the fan hums and the monitor fades to black. Somewhere beyond sight, the traveller keeps going, and Mars turns quietly in its wake. Morning again, and the first thing you notice is that the air feels lighter, as if the universe exhaled overnight. The news feeds are alive, finally. With the government shutdown over, NASA's public channels flicker back to life, dusty from neglect but suddenly glowing with activity. It's like someone turned the lights back on in a planetarium after too long in the dark. The first official statement you read is predictably cautious. We thank our international partners for continued observation of Object C/2025 P1 ATLAS. They still refuse to call it 3I, but everyone else does. Even formality can't stop a good nickname. You scroll further. There it is, the first spectral analysis from the reopened servers. Rows of wavelength data, peaks and valleys like a strange seismograph of colour. You can't help smiling. The ESA and Chinese teams had already released preliminary readings, but NASA's report is different. Tighter, more detailed, humming with the authority of institutional understatement. The key finding sits halfway down the page. Spectral fingerprints show mixed signatures of organic volatiles, metallic silicates, and an unidentified emission line near 327 nanometers. You whisper the words aloud, unidentified emission line, and they sound like a secret being told in code. Historians still argue whether a similar unidentified line in 1910's Halley's Comet spectra led directly to the discovery of cyanogen, or whether it was pure coincidence. Maybe every great discovery begins as a line no one can explain. You copy the data into your notes and plot it yourself, connecting the dots like a child tracing constellations. The curve looks uneven, almost layered. The metallic signatures imply fragments of iron and nickel, but the organic volatiles, methanol, formaldehyde, speak of chemistry, of possibility. You imagine each molecule forming long before Earth existed, deep inside a forgotten nebula, preserved in ice for billions of years until this week, when sunlight and Mars's proximity coaxed it into radiance. The thought makes you dizzy with perspective. A new report arrives from the UAE's HOPE probe. Ultraviolet readings show oscillating brightness in the same frequency range as the ESA heartbeat pulses. That's not coincidence anymore. Something within Atlas is resonating. The scientists hesitate to call it periodic behaviour. They prefer cyclic photometric modulation. But you know pattern when you see it. The object brightens every 5 seconds, as steady as a metronome. A friend in an amateur group messages you, could it be rotation? Maybe. Or maybe something deeper. You type back, historians still argue whether Oumuamua's tumbling motion created its own light curve. History might be rhyming. You switch to NASA's second release, a close-up from the Mars Reconnaissance Orbiter's high-resolution camera. The image is grainy, but there's detail, streaks across the surface, faint concentric ridges that almost look carved. Probably natural fractures from outgassing, you tell yourself. Still, the symmetry is unnerving. The ridges spiral around the core like fingerprints. You zoom in until the pixels blur, trying to decide whether you're seeing geology or geometry. The line between them feels thin tonight. Another notification buzzes. The Perseverance team has published their log from October 2nd, the day of the streak. They confirm the unidentified object passed within visual range of the rover's mast cam. You grin, validation at last. Object trajectory consistent with orbital predictions for C/2025 P1, ATLAS, the note reads. Confirming first extraterrestrial observation of an interstellar body from another planet's surface, you whisper a small yes to the empty room, a cheer swallowed by your own awe. That single sentence redefines planetary astronomy. For the first time, humanity has observed an interstellar traveller from 2 worlds at once. You glance out the window as if expecting fireworks. There are none. The street below carries on with morning routines, delivery trucks, joggers, the mundane gravity of life. Yet above that ordinariness, an object older than your species is being dissected by instruments you helped fund with tax dollars and daydreams. The contrast makes you smile. Scrolling again, you find commentary from a NASA spectroscopist addressing the mystery line near 327 nanometers. We're considering complex organics, she writes. Possibly polycyclic aromatic hydrocarbons altered by radiation. You nod. That's the kind of molecule life eventually borrows for its own chemistry. No aliens, just ingredients. But you can't shake the thrill of the word organic. Historians still argue whether the discovery of amino acids in the Murchison meteorite truly proved cosmic prebiotics, or was just contamination from Earth. Maybe Atlas will settle that one day. The day drifts on in a rhythm of refreshes and revelations. A Reddit thread compiles all the datasets into a single colour composite. An emerald orb wrapped in faint violet shells. The invisible tail turned sunward. One user jokes, "It's the universe's mood ring." Another posts, "If this isn't proof of alien minimalism, nothing is." You laugh out loud. Humanity will never stop turning data into art. Late afternoon sunlight spills across your desk. The fan hums, echoing that 5-second pulse you've been tracking. You tap your pen in time with it, a metronome of discovery. Somewhere beyond your window, the Deep Space Network's antennas are swiveling, catching photons that left Mars 20 minutes ago. Inside those photons are spectral fingerprints that might rewrite the story of chemistry, or perhaps nothing new at all, just old atoms humming in familiar patterns. Either outcome feels sacred. You pause to reread your notes. Spectral fingerprints, organic volatiles, unidentified line. Each phrase carries its own gravity. The longer you stare, the more you realise that unidentified is the most beautiful word of all. It's the word that keeps telescopes built, keeps servers humming, keeps sleepless people like you glued to screens long after common sense says rest. You smile at that. Curiosity is humanity's most reliable addiction. As the sky darkens, you turn off the lights and watch the faint reflection of your monitor on the glass. It looks like a miniature galaxy floating in your room. You imagine somewhere out there, Atlas spinning slowly, glowing faintly green, still whispering its periodic rhythm into the void. The thought settles over you like a blanket. You whisper, "Keep singing." The fan ticks once, perfectly in time, as if answering. You wake to silence so deep it feels almost staged, the quiet after a standing ovation. For a moment you think the power's gone out again, but then you realise it's the data feeds. Nothing new since last night. The world has gone from frenzy to fatigue, scientists sleeping off adrenaline, journalists moving on to fresh headlines. You sit up slowly, the afterglow of Atlas still pulsing in your mind. There's something strangely intimate about a global pause. The comet, or whatever it is, keeps moving, but we've stopped to breathe. You make tea instead of coffee this time, needing calm more than caffeine. The fan hums softly, like an instrument waiting for its next cue. As you sip, you pull up the last data you downloaded before the servers went quiet. Spectral fingerprints overlay light curves, acceleration graphs, all telling a story too complex for language. You trace your finger along one jagged spike, the 327 nanometer mystery line, and feel an odd tenderness for it. It's just a photon count, a glitch maybe, but it has personality. You think about how historians still argue whether the first X-ray spectra were misread smudges or the start of modern physics. Every discovery begins as a blemish someone cared enough to investigate. The headlines trickle back in slowly. Government reopens, NASA resumes normal operations. Scientists pledge transparency on 3i/Atlas. But the tone has changed. What was once breathless wonder now sounds like bureaucratic damage control. Press officers use words like anomalous chemistry instead of unprecedented discovery. The thrill has been flattened into professionalism. You understand, they have to sound calm, but you still miss the honesty of awe. There's a safety in understatement, but it leaves the story feeling half told. A live briefing begins mid-morning. 3 scientists stand behind a lectern in Houston, looking sleep-deprived but exhilarated. The first explains that the non-gravitational acceleration is within expected ranges of gas jet propulsion due to volatile sublimation. The second adds, we cannot rule out unknown outgassing vectors. The third, a younger woman with steady eyes, leans into the microphone and says quietly, however, we have no evidence of any engineered propulsion system. You admire her composure. She's addressing questions no one asked aloud, but everyone was thinking. They show new graphics, models of rotating ellipsoids, thermal maps, particle simulations. You watch the coloured blobs twist on screen, half science, half art. In the margins of the chat window someone types, "So? Still weird then?" You grin. The official line may be tidy, but the mystery remains intact. The comet refuses to behave neatly, and that's its most human trait. After the briefing, you scroll through a long essay posted by a historian of science. Moments like this, it begins, remind us that wonder is not a resource to be conserved, but a pulse to be felt. The phrase lodges in your mind. The writer compares the shutdown silence to the early days of radio astronomy, when blank channels were as meaningful as signals. When science meets shutdown silence, he writes, it discovers its own heartbeat. You copy the line into your notebook, drawing a small heartbeat symbol beside it. By afternoon, the feeds start populating again. Cleaned images, processed spectra, revised trajectories. The numbers whisper that Atlas has already begun to fade, its brightness dropping steadily as it races toward perihelion. The public excitement will fade with it. You feel a strange melancholy at that thought, like the end of a concert when the last note dissolves into applause. You open the first Namibian photo again, the one that started your obsession, and stare at the green smear until your eyes water. For a second, you imagine you can feel its motion inside your chest. Outside your window, clouds roll in, bruised with sunset. You step out onto the balcony, the air smelling faintly of rain and exhaust. The city hums beneath you, oblivious to cosmic dramas. You think about the engineers scattered across continents, each watching their part of the data stream, each wondering if they've glimpsed something unexplainable. There's comfort in that shared uncertainty. Maybe science is less about answers than about synchronized curiosity. You go back inside and turn off the screens. For the first time in days, you let the room be dark. The fan's rhythm fills the silence, steady and hypnotic. You close your eyes and picture the deep space network antennas still tracking, their giant dishes tilting through the night. You imagine the data packets racing home, each one carrying a few photons from a place no human will ever visit. It feels almost sacred, information as prayer. a final message pings on your phone. Atlas signal confirmed stable. Post-CME drift nominal. The words are cold, but you read between them. Stable means alive, nominal means still mysterious. You smile, finishing your tea. The government may have reopened, but the universe never closed. You jot one last line before bed. Silence and signal are the same story told in different languages. Then you close the notebook, set it on the desk beside the dark monitor, and let the hum of machinery lull you towards sleep. Somewhere, the interstellar traveller keeps moving, carrying its secrets out of the inner system while the world below learns how to listen again. By the time you open your eyes again, another week has slipped by, but space doesn't care about human calendars. Outside, the leaves on the street trees have turned copper overnight, a soft echo of the red planet you've been following through every dawn. You make coffee, heavier this time, and glance at the headlines. The European Space Agency has handed the next phase of monitoring to their outer system partner, JUICE, the Jupiter Icy Moons Explorer. You remember its quiet launch years ago, designed to study Ganymede and Europa, not interstellar comets. Now somehow it's been drafted into this cosmic relay race. You read the press summary twice to be sure. Because of orbital geometry, the spacecraft is currently on the sunward side of the inner solar system, its instruments temporarily free of Jupiter's interference. For the next few weeks before perihelion, JUICE will attempt long-range tracking of 3I/Atlas as it slings toward the sun. The plan sounds insane. A probe built for frozen moons trying to photograph an object blazing at 68 kilometers per second. But insanity and inspiration often share an orbit. Historians still argue whether the Voyager engineers were reckless or visionary when they decided to photograph the pale blue dot. You decide to side with vision. You scroll through the mission logs. ESA calls this an opportunistic observation, meaning they're doing it mostly because they can. The line makes you laugh, so human, so casual in the face of cosmic choreography. You picture the spacecraft spinning slowly in sunlight, cameras recalibrating, gyroscopes humming. Its silver panels catch the same solar wind that's about to whip across Atlas's surface. In the schematic animation, their trajectories look like two threads briefly intertwining before diverging forever. Somewhere between them lies the invisible zone where photons trade secrets. You pull up a fresh star chart tracing where the object will appear relative to the Sun at the end of October. For a moment you think about grabbing your own telescope, though you know it's hopeless. Too close to the glare, too dangerous for your optics. Still, the thought warms you. Watching through screens has its limits. Sometimes you need to squint at real sky, even if you see nothing. You step onto your balcony and do just that, feeling the early chill of autumn while invisible objects cross each other, millions of kilometers away. Back inside, you open a live feed from ESA's control room. Rows of blue-lit consoles, a slow piano track looping underneath. The mission lead explains in calm tones that JUICE will perform intermittent scans between telemetry uploads. The timing isn't ideal. The spacecraft will pass briefly behind the Sun from Earth's perspective, a period they call solar conjunction. Communication will be patchy for months. That means any data collected now won't reach us until February, maybe later. You stare at the screen, a little heartbroken. Discovery deferred is still discovery, but it feels like reading the first page of a book you won't finish for half a year. The commentator continues. We will likely lose continuous contact from late October through mid-January due to solar interference. He says it like a forecast of mild weather, but you hear something else in his tone, a quiet resignation. You imagine the spacecraft out there, continuing its work while its home planet forgets to listen. The image is oddly comforting. Curiosity doesn't depend on applause. You open a sidebar thread where amateur astronomers debate what JUICE might actually see. Some think the object will brighten dramatically near perihelion, others predict it will disintegrate, another cosmic snowball undone by heat. Someone jokes that it will evaporate into pure speculation. The humour helps. You type your own small comment. Maybe it will leave something behind for Jupiter to find. You get 5 likes, which feels like a handshake in a room full of strangers. Later you switch to NASA's revived Mars feed. The Perseverance rover is busy again, drilling rock cores, turning its mechanical head away from the stars. Life goes on even after miracles. Still, in one photo, the sky over Jezero crater looks subtly different, brighter, washed in faint gold. You know it's just exposure balance, but you pretend the interstellar visitor left a fingerprint in the air. Afternoon fades into evening. The news outlets have moved on to terrestrial crises, but you remain tethered to your cosmic thread. You reread the ESA statement, noting one quiet sentence near the end. Due to expected communications blackout, full analysis of JUICE data will resume February 2026. That date glows in your mind like a promise. You imagine yourself months from now, older, still waiting, still curious. There's something strangely liberating about delayed revelation. It gives wonder time to mature. You set your pen to paper and sketch a timeline. Discovery in July, CME in September, Mars flyby in October, solar conjunction ahead. Each event feels like a heartbeat. Beneath it you write, the universe paces itself. Then, just below that, patience is the price of scale. The second line makes you chuckle. It sounds like something carved on a philosopher's tombstone, yet it feels true. As night settles, you let the monitors dim until only their standby lights remain. Tiny, artificial stars in your room. You picture JUICE gliding silently through the dark, its instruments turning toward a distant green flicker. No one will hear from it for months, but somewhere inside its circuits data accumulates. Photons, spectra, faint hums of radio noise. The universe doesn't stop speaking just because our receivers are temporarily deaf. You close your notebook, whispering a quiet goodnight to the ship and the comet both. In your mind, they're not machines and rock, but travelers passing each other in the great interstellar dusk. One carries questions, the other perhaps carries answers. You fall asleep imagining their paths crossing in slow motion, like two fireflies blinking once in recognition before the dark swallows them again. The calendar flips to late October almost without permission, and with it comes the quiet milestone that every stargazer has been whispering about. Perihelion, the point of closest approach to the Sun, the object 3I/Atlas, green, stubborn and still half unnamed, now burns through the brightest patch of sky humanity has ever failed to see directly. From Earth, it's lost in glare. From Mars, the orbiters have already turned away to protect their sensors. Only JUICE, now slipping behind the Sun from our vantage point, keeps its mechanical eyes open. You sip your coffee and stare at the ESA page that says simply, "Transmission dropout expected within 48 hours." It's a strange sentence, clinical, almost indifferent, but you feel the weight of it. Transmission dropout means silence, and silence in space is never casual. You read what little data trickled in before the blackout. The comet's brightness has spiked tenfold in less than 3 days. That shouldn't happen unless it's disintegrating, or doing something unprecedented. ESA's language, careful as ever, calls it a high-energy albedo anomaly. Historians still argue whether similar surges in Tui/Borisov's final approach were just outgassing bursts or hints of structural collapse. Either way, something inside Atlas is waking up or tearing apart. You stare at the light curve on your screen, a smooth line that suddenly shoots upward like a heartbeat gone wild. The online chatter has ignited again. Amateurs, professors, dreamers, everyone's tossing theories into the digital bonfire. One camp says it's fragmentation. The nucleus is breaking into shards that reflect more sunlight. Another says the opposite, that it's stabilizing, hardening into a solid core as volatile material burns away. And then there's the third camp, the one that whispers engineered event like a prayer. You try not to roll your eyes, but you read them anyway. Wonder and madness always travel together. Outside, the afternoon light looks sharper than usual, as if the sun itself knows it's part of the story. You step onto your balcony and close your eyes against the glare. Somewhere beyond that brightness, an object from another star is looping through our inner system, brushing the fire of creation and surviving. Maybe. You think about what that means. Billions of years adrift, one brief intersection with our sun, and then exile again into the dark. It feels both tragic and holy. Back at your desk, you pull up archived data from Oumuamua and compare it to Atlas's curve. The similarities make you pause. Both show subtle, non-gravitational accelerations around perihelion. Both spin irregularly, both refuse to behave like ice. But Atlas's brightness is higher, its composition stranger. Its green glow remains constant even as it flares, like a light bulb dimming but never changing color temperature. You jot in your notebook, internal excitation rather than reflection, magnetic confinement layer, It sounds absurd, but then again, so did every great theory before someone tested it. You check the time, ESA's final telemetry window before solar conjunction should open any minute. You refresh their live feed compulsively, watching the status bar flicker between receiving and no signal. The chat beside it fills with anxious messages. Anything yet? Telemetry stable? Still green? Then the feed freezes. A single line of text appears. Data acquisition suspended due to solar interference. And just like that, the world goes quiet again. You lean back and let the silence spread through your room. It's a peculiar feeling, knowing that something extraordinary is happening right now, but no one can see it. Maybe that's the truest form of awe, not in observation, but in surrender. You remember an old philosophy lecture about negative space in art, how what isn't drawn defines what is. Maybe astronomy works the same way. Maybe the gaps in our knowledge are the constellations, not the stars themselves. The forums react predictably. Memes flood in within hours. Black squares labelled latest image of 3i/Atlas. Screenshots of the transmission dropout notice turned into mock movie posters. Yet beneath the humour lies genuine yearning. The silence hurts because it's honest. It reminds us that we are still small, still mostly blind. You scroll through comment threads until one message stops you cold. It's from a user calling themselves Namib Skywatcher, probably Gerald Raymond again. He writes, "It's beautiful that we can't see it. That means it's still free." You copy the line into your notes. Evening stretches on, warm and slow. You make dinner but barely taste it. Every few minutes you check the ESA page, though you know the blackout will last months. Still, hope is a reflex. The world around you feels oddly still, like a held breath. Maybe the entire solar system is waiting too. You think of JUICE out there still moving, its instruments silently logging whatever photons reach its sensors. You imagine Atlas at that same moment, wrapped in its emerald haze brushing the edge of the sun's domain. You switch off the lights and sit in the glow of the monitor's standby LED. One green dot, steady, patient. You can almost pretend it's the comet itself, a miniature echo of cosmic colour. You breathe in and whisper, "Don't burn out." Your notebook lies open beside you, the last page filled with scattered thoughts, heartbeat pulses, spectral line, solar silence, freedom. You underline the last word and close the cover. The hum of your fan fills the void, soft as static. You realise this silence doesn't feel empty anymore. It feels full, like a held chord waiting for resolution. Somewhere behind the sun, a stranger from another world is writing that chord's next note. You fall asleep at your desk, the screen still glowing faint green, your dream filled with light that hums instead of burns. When you wake, winter has begun to edge its way into everything. Longer shadows, colder mornings, the quiet crackle of heat through the pipes. The world has moved on from the green wanderer. News cycles have turned toward elections, storms, sports. The algorithms assume your fascination should have faded with the headlines, but it hasn't. The ESA's site still lists JUICE under In Conjunction Blackout, and NASA's pages offer nothing new. Just a looping reminder that communication will resume once the sun moves out of the line of sight. You pour your coffee and stare at that single sentence for far too long. Communication will resume. You wonder whether that's a promise or just a hope disguised as policy. You've started living by a new kind of calendar, the slow celestial one. Every morning you check the solar position, calculating how much closer we are to the moment when JUICE's antennas can speak again. 92 days of silence so far. You imagine the spacecraft gliding through that quiet like a blind swimmer, instruments still running, recording light that no one will read for months. The thought comforts you. In a world that runs on instant answers, patience feels like rebellion. Historians still argue whether the centuries-long wait between Galileo's sketches and Hubble's photographs changed human humility or just its technology. You decide it's both. The forums haven't died entirely. A small, stubborn core of enthusiasts still post daily, tracking the object's predicted path beyond perihelion. The models suggest Atlas survived its solar encounter. That alone is improbable. Most comets, especially interstellar ones, tend to disintegrate under that much heat. Yet brightness estimates from the SOHO satellite show a faint point still moving outward, dimmer but intact. The label beside it reads P1-Atlas, stripped of its 3i prefix as if the data teams themselves are hedging their bets. You whisper, "Still here," like you're greeting an old friend. Your notebook is almost full now. Every page carries fragments, numbers, sketches, stray thoughts. Some nights you flip through it like a diary of the cosmos. Early entries are breathless, interstellar object confirmed. Later ones grow quieter, waiting for transmission. Tonight's page begins differently. You write, objects that survive the sun deserve respect. You don't know why, but the sentence feels heavy, like something larger than you wrote it through your hand. You scroll to see what little new data exists. The amateur astronomers are back at work, posting long exposure images of dawn skies. One frame from Chile shows a faint green smear again, barely visible above the noise. If the coordinates are right, Atlas has already cleared the orbit of Venus. Its colour hasn't changed. Whatever chemical engine paints that green glow, it refuses to fade. You think of the object as stubborn, even proud, its own kind of perseverance. You wonder if machines like JUICE can feel admiration. Afternoon slides toward evening and the chill deepens. You turn on a small lamp, its yellow glow soft against your desk, and begin rereading old press releases. You notice a sentence you'd missed before. JUICE's instruments will continue passive observation even during conjunction, storing data locally until communications are restored. That means the spacecraft hasn't stopped watching. Right now, somewhere beyond the sun, it's still collecting light from the fading traveller, stockpiling secrets for later delivery. The idea steadies you. Not every silence is absence. Some are archives in progress. To distract yourself, you dig into past records of other celestial blackouts. When Voyager 2 went behind the sun in 1982, Earth lost contact for 40 days. When the Mars Reconnaissance Orbiter did the same in 2006, engineers left it a simple message: behave while we can't hear you. You smile at that. Maybe someone at ESA whispered something similar to JUICE before its own descent into radio shadow. You like to imagine a room full of engineers saying goodnight to a machine that won't answer for months, like parents sending a child off to camp at the edge of forever. As night falls, you light a candle on your windowsill, a habit you've picked up during this long wait. Its flame wavers against the glass, reflected twice, a tiny mimic of a star. You think of Atlas's green glow shrinking into darkness, of Juice's cold sensors staring into sunlight, of Earth spinning between them. All 3 points, comet, machine, human, linked by the fragile thread of curiosity. That thought feels like warmth itself. You check your feeds one last time. A post appears from an ESA staffer, brief and almost apologetic. Signal reacquisition expected mid-February. Preliminary handshake attempts in progress. The words jolt you upright. Handshake attempts. Such a simple, human phrase for cosmic distance. You picture the spacecraft stretching its radio arm through a haze of plasma, calling out across 90 million miles of interference. You imagine the antennas on Earth listening, dishes tilted skyward like open palms. The signal will come eventually. It always does. You close your notebook and rest your hand on its worn cover. For the first time in months, the waiting doesn't feel endless. It feels like a countdown to reunion. Somewhere beyond sight, a data buffer fills with photons from a visitor who refused to die in the sun. Somewhere closer, engineers rehearse the words they'll say when contact returns. And here, in your small room full of paper and hums, you whisper your own greeting ahead of time. Welcome back. Outside, snow begins to fall, silent, precise, cosmic in its own miniature geometry. Each flake catches the lamplight, tiny comets burning briefly before melting away. You watch them drift and think with a kind of peace that maybe the universe sends reminders in every scale it can. Then you close your eyes, letting the quiet fill in the rest of the story you'll hear soon enough. The first whisper comes in the middle of February, right on schedule, just as ESA promised, though the announcement feels more like the sound of a door creaking open after a long winter. You're half asleep when your phone buzzes, the notification light painting the room pale green. Signal reacquired, Juice operational, data transfer initiated. That's it. No fanfare, no headline-level adjectives, just a line of text that makes your heart race. You sit up so fast that your blanket collapses to the floor. 92 days of silence undone in 7 words. The traveller has phoned home. Within hours, the internet lights up like an aurora. Mission control confirms the handshake succeeded. All instruments nominal, data backlog immense. The first files are being downlinked now, compressed packets of photons, dust signatures, spectra, all of it recorded during Atlas's final dance near the sun. You picture engineers leaning forward in dim rooms, their faces lit by graphs and code, their voices calm but trembling. You refresh ES's live blog until the page nearly freezes. Finally, a statement appears. Initial light curve review suggests object maintained integrity throughout perihelion. You whisper the words aloud. It survived. Again. For the next 2 days, your world shrinks to screens and signals. Data drips through the deep space network like snowmelt, slow but unstoppable. The first images arrive, raw, monochrome, each tagged with timestamps from December and January. You watch as analysts on forums convert them into false colour, aligning frames, stretching contrast. Out of the static emerges a faint sphere glowing not just green anymore, but edged in ultraviolet and violet. Something changed out there. ESA's spokesperson calls it spectral diversification. The phrase sounds elegant, but you know what it means. The object began reflecting wavelengths it never showed before. That suggests surface transformation, maybe melting, maybe exposure of deeper layers. You imagine the outer crust boiling off, revealing an inner lattice, some crystalline structure catching new light. Historians still argue whether the first cometary jets photographed by Giotto in 1986 proved internal structure, or were merely shadows of uneven terrain. Atlas seems to be rewriting that argument on an interstellar scale. Another feed opens, a Chinese scientist summarizing joint analysis. We observe a rotational stabilization event, she says through a translator. Object spin rate decelerated sharply after perihelion, consistent with redistribution of mass or controlled emission. Controlled emission. The words hang in the air like incense. She doesn't mean control in the human sense, of course. She means physical equilibrium. Still, the phrasing feels poetic. The object didn't die. It steadied itself. You spend the next evening watching ESA's composite reveal, broadcast live from Darmstadt. Rows of monitors, the room's lights dimmed. When the final image resolves, everyone in the feed goes silent. There it is, 3i Atlas in its post-solar state, trailing a faint ring-like halo, almost symmetrical, its colour more turquoise now than green. No visible fragmentation, no tail, just serenity. Someone whispers, "It looks sculpted." Another voice answers, "It looks healed." You find yourself nodding. After all that heat and violence, the traveller seems whole again, as if the sun burned away weakness rather than life. The chat fills with awe. A student asks if the halo could be magnetic flux. An engineer replies that readings show polarized light consistent with a structured field. The possibility stuns everyone. Polarization implies order. You scribble in your notebook. Ordered magnetism, sustained charge, self-generated confinement. You don't know enough plasma physics to chase it further, but the thought that an interstellar object could organize its own magnetosphere feels like something out of science fiction. And yet the numbers say it's real. Historians still argue whether cometary magnetism was first confirmed during Rosetta's mission to 67P, or if earlier probes hinted at it decades before. But this isn't a faint hint, it's a symphony. ESA's graphs display oscillations, perfect 5-second pulses just like the earlier heartbeat pattern. That rhythm survived solar hell intact. The commentators are cautious, but you can tell they're enchanted too. We can't confirm internal causation, one says, but the periodicity is unusually precise. You grin. The heartbeat lives. Outside your window, the night seems to shimmer. You step out into the cold, phone in hand, reading the live transcript of the press briefing. We believe Atlas may now be electrically charged at macroscale, says one researcher. It interacts with solar wind not as passive dust, but as an active plasma body. You breathe out into the frosty air, watching your own breath form a tiny cloud. For the first time in months, you feel that same shiver you felt at the start, the sense that something vast has leaned a little closer to say hello. Later, as midnight settles, you open your journal to a blank page and write, "The traveller survives the sun, changes colour, and sings in time." You underline the word sings. It feels accurate. The data pulses really are a song, measured in radiation instead of sound. You imagine them converted into audio, faint, slow beats like a cosmic metronome. Maybe one day someone will play them in a planetarium, letting children fall asleep to the rhythm of an interstellar visitor's pulse. You scroll one last time before bed. NASA's new statement arrives, brief but poetic for a government agency. C/2025 P1 Atlas remains intact and is moving outward on a hyperbolic trajectory. It will not return. You stare at that last sentence, tasting its finality. Will not return. The universe, generous but unsentimental, never grants sequels, yet somehow you're at peace with it. The story doesn't need repetition, it just needed to be told once, beautifully. You close your eyes, hearing that 5-second rhythm echo in your imagination. Maybe it's just your heart syncing with distant plasma, maybe it's something older. Either way, you fall asleep smiling, the quiet certainty of survival glowing behind your eyelids like a soft turquoise dawn. By late March, the headlines have thinned again. The world has a short attention span, the cosmos does not. Atlas, now well beyond the orbit of Mars and racing outward at nearly 70 kilometers per second, is already a fading spark in most telescopes. You sit at your desk on a Sunday morning, the same way you have for months, scanning data summaries like morning prayers. ESA has published its final consolidated report. 60 pages of charts, spectra, and language so careful it feels almost shy. You scroll through it slowly, knowing you're nearing the end of something that has shaped your days. The summary begins with facts. The object maintained coherence, emitted structured electromagnetic pulses, and exhibited a persistent green to turquoise chromatic shift. The report calls it evidence of photochemical transformation of carbon-bearing compounds under intense solar radiation. Translation: the sun painted it differently. You imagine those carbon molecules rearranging themselves in the heat, turning chaos into pattern, a metamorphosis written in chemistry rather than myth. Historians still argue whether the same process on early comets once seeded Earth's oceans with organic material. Perhaps Atlas isn't just a visitor, it's a memory of beginnings. You pause over the section labelled Rotational Dynamics. The spin slowed dramatically post-perihelion, then stabilised at gentle 2 rotations per hour. Some call it coincidence, others whisper about self-regulation. There's no need to anthropomorphise physics, one researcher writes, and you nod, smiling, because of course there isn't. But we will anyway. Humans can't help but project purpose onto persistence. When something survives, we assume it wanted to. The next pages detail JUICE's magnetometer readings. The graphs look like seismographs of a sleeping giant. Oscillations every 5 seconds, perfectly steady, lasting weeks. ESA labels them periodic magnetic flux modulations of unknown origin. Unknown origin, the scientist's most honest sentence. You imagine the spacecraft, now millions of kilometers farther out, still humming quietly with the afterglow of that field. You picture those waves of invisible energy brushing across the solar wind like the slow strum of a galactic harp. Scrolling farther, you find an appendix titled Interagency Coordination Notes. It lists the credits: ESA, CNSA, UAE, and finally NASA. The names form a constellation of cooperation. For once, the world remembered how to look outward together. You trace your finger along the acronyms, thinking how fragile that alliance is, and how wondrous that it ever existed at all. For a few months at least, politics obeyed physics. The shutdown that had nearly silenced everything now feels like a myth you half dreamed. You click the final link, a high-resolution composite of Atlas from its last confirmed observation window. The image loads slowly, pixel by pixel, until the full form glows on your screen. The nucleus shines a calm blue-green, surrounded by an even halo, no tail, no debris. It looks less like a comet now and more like a gemstone suspended in darkness. You zoom in, expecting noise, but instead see faint striations radiating from the core like the spokes of a wheel. They're subtle, mathematical in spacing. Optical artifact perhaps, but beautiful. You whisper, "You're tidier than we deserve." The closing paragraphs of the report are cautious. Further observation will be infeasible beyond 4 astronomical units, it says. The object's hyperbolic excess velocity ensures it will exit the heliosphere within approximately 12 months. After that, Atlas will rejoin interstellar space, heading toward no one, carrying whatever stories we projected onto it. The universe doesn't archive sentiment, only motion. Still, the line stings. Exit the heliosphere. You picture it slipping through the solar wind boundary like a swimmer breaching from warm water into a cold sea. No applause, no farewell, just endless dark. You minimise the report and open your old notebook. Its pages are swollen from months of scribbles, equations, metaphors, midnight sketches. The first page bears your early excitement, the last is nearly blank. You uncap your pen, and after a moment of thought write, "The traveller leaves, and the silence it carries is not emptiness but continuation." Then beneath it, in smaller letters, historians still argue whether wonder ever ends or just changes address. You close the book gently, as though tucking in a child. Outside, evening settles. The first spring wind rattles the windows, a sound like static from the stars. You switch off the lights and stand by the glass. Far beyond that twilight, a green dot you'll never see again is still moving outward, steady as a heartbeat, indifferent but magnificent. You think of all the people who watched it, scientists, amateurs, skeptics, dreamers, and realise it changed everyone in small ways. Maybe that's all celestial visitors are meant to do, remind us that transients can still illuminate. You make one last note on your phone before bed, more a whisper than a sentence. We watched it arrive, we learned its rhythm, we let it go. Then you set the phone aside, the screen dimming to a single faint glow. For a moment it looks exactly like the object you've been chasing for months, one stubborn light against darkness. You lie down and listen to the house settle, each creak echoing the slow spin of the universe. Somewhere, photons still travel from that turquoise shell toward you, destined never to arrive, stretching thinner with every mile. You close your eyes and imagine them brushing your face anyway, light years too late but perfectly on time.